All right, fellas. Well, it's 4 o'clock, so... Yeah. I'll leave a shulk here, Panta. I just noticed the time. I'll leave a... Smooth stone slab. That has nothing in it. I'll leave an empty shulk here. If you guys want to throw that stuff in there, that would be really helpful. Yeah, I'm gonna take a break time now, dudes. Oh, Panta, you're my hero. Thanks, dudes. Alright. Fellas, GG. Alright. Enjoy. That was fun. Probably work on that a little bit later. Okay, what are we watching tonight? I'm looking around. Okay, let's switch over to science and technology. Sweet. All right, let me find us a documentary. You want We Deliver? Oh, okay. That makes it easy for me. I don't know, Ben. A lot. All right. Yep, okay, this is the right one. Alright, fellas. I'm gonna give you guys a little bit of a sound boost.
Yeah, we see it down here,
Alright,
it's beautiful.
I'll be back in a little bit. Jim, thank you for the resub. Be back in a second.
Roger, we copy. You guys look good. And Columbia, Houston, everyone down here is go for deploy with 2 minutes left over Hawaii.
And so is everyone up here.
Roger, we copy.
Mike, we hope the TV comes out. It doesn't play back very well on a monitor, but we're relatively sure we got it. And we, by the way, still have that beautiful satellite inside. It's traveling just below it.
Roger, we copy, Bill and Joe, and got a lot of happy people down here. You guys did good work.
Okay, Mike, we delivered. We got SBS off on time, and if you're interested, I'll read you the pad.
Roger, go ahead.
Deliver the crew of Shuttle Mission 5 did. Only 8 hours into the first operational flight of the Space Shuttle program. 5th flight of the orbiter Columbia. The first 4 missions were test flights to prove the space transportation system could provide access to low Earth orbit on a routine basis. Those missions laid the groundwork for the operational era. Shuttle Flight 5 was the beginning of that era. The primary purpose of the mission, to carry 2 communication satellites into orbit, deploy them from the payload bay, then return to Earth.
Columbia, Houston, 30 seconds till LOS, and everything is still go down here for deploy.
Roger, Brian, we copy that. Thank you very much. We're looking forward to having a good one.
Roger, and good luck.
Okay, Houston, this is Columbia. We are 2 for 2. We deliver. Hey, Roy, are we down now? That was, are we on the ground?
Absolutely.
A flawless landing. Only minutes after sunrise at Edwards Air Force Base, California, ended Columbia's 5th mission. Looking slightly weathered, the orbiter had traveled over 10.5 million miles in 5 flights, spent 24 days on orbit, and circled the Earth almost 400 times. It would now return to Kennedy Space Center, Florida, for refurbishment, to be launched again on Shuttle Flight 9. The newest orbiter in NASA's fleet, Challenger, would fly on Shuttle Flight 6. Many weight-saving improvements had been made. The orbiter itself was almost 2,500 pounds lighter because of structural changes. The external tank weighed 10,000 pounds less than the one used on Shuttle Flight 1. The solid rocket boosters were almost 4,000 pounds lighter. The 3 main engines were upgraded to 104% of rated thrust. A blanket-like thermal material replaced 600 thermal tiles in non-critical areas, and all 30,000 tiles were densified to improve their durability. This stack could carry over 17,000 pounds more into orbit than Columbia.
Minus 15, 14, 13, 12, 11, 10. We'll go for main engine ignition. 7, 6. We have main engine ignition. And liftoff. Liftoff of the Orbiter Challenger and the 6th flight of the Space Shuttle. The shuttle has cleared the tower.
Challenger's underway. We got a roll program.
Houston copies, Challenger. And some late news for you, Story. We got a go for deploy. We have a go for deploy.
On Shuttle Flight 6, Challenger's cargo, the Tracking and Data Relay Satellite, TDRS, and its solid propellant inertial upper stage rocket, the IUS, weighed almost 19 tons. TDRS was the largest, most advanced communication satellite launched to date,
That is correct.
a major accomplishment in space communications. TDRS is launched from the payload bay by ejection springs, released when explosive bolts are fired. After shuttle moves a safe distance away, the first stage of the IUS rocket fires to boost the satellite from 150 miles to 22,300 miles in altitude. Then the first stage separates. Shortly thereafter, the second stage of the IUS rocket fires to circularize the satellite's orbit. Solar panels and antennas are deployed to provide power and tracking and data relay capability. Having attained a circularized altitude of 22,300 miles and traveling at the same speed as the Earth's rotation, the satellite will remain fixed in orbit over the same location continuously. Later, the first TDRS will be joined by 2 more identical satellites. The 3 will form a space communications network, providing almost continuous coverage to Earth-orbiting spacecraft, not the 15% ground stations provide. The network will be able to track 26 Earth-orbiting spacecraft simultaneously. And because TDRS satellites only relay data, they do not process it, 20 times more information will be handled by this network than could be by ground stations. All data will be relayed directly to the primary NASA ground terminal, White Sands, New Mexico, and from there via domestic satellite to other NASA centers.
Hello there, we're with you over...
Launch of TDRS was on time and nominal. First stage firing of the inertial upper stage also went well.
And Sunnyvale and White Sands send you a special attaboy.
However, halfway through the second stage firing, ground controllers lost communication with the satellite. It was an hour before even intermittent signals were picked up. They indicated TDRS had not yet separated from the IUS, and that both were tumbling at a very high rate of speed. Receiving only intermittent signals from TDRS, using short-life batteries which would soon be depleted, and getting no response to signals sent from the ground, made the outlook for TDRS bleak. Several more hours passed, and then something remarkable happened. Experts still aren't sure why, but either an automatic timing mechanism was engaged, or onboard systems finally acknowledged repeated commands from the ground, separating TDRS from the IUS.
Well, I do have some words.
Now on its own, the satellite stopped tumbling. Ground controllers commanded deployment of the solar array and antennas. However, they quickly learned TDRS was way off course and drifting farther every day. Their only hope of getting it back on course was to use the tiny hydrazine thrusters originally designed for minor attitude and velocity adjustments, not for boosting the 2.5-ton TDRS over 8,500 miles farther into space. But at least the satellite was not lost. NASA officials immediately put their plan into effect. Meanwhile, Shuttle Flight 6 continued as planned.
Okay, we're back with you, Mila, for about 12 more minutes. Got a good TV picture again.
Roger, Houston. Got the hatch closed, and we're waiting for a go for depress on time.
That sounds great, Bo.
Copy, we have a go for depress on time.
That's affirmative. You have a go. And Challenger Houston's with you over Guam for about 7.5 minutes.
Roger, hatch is open. EV1 is halfway out. They're configuring the airlock, getting ready for Dawn to come out.
Okay, we're watching.
Houston, they have a suggested setting for the DAC camera now in the sunlight. Okay, Dawn.
This was America's first spacewalk in 9 years. The astronauts were attached by safety tethers to slide wires running just inside the payload bay. They wore a new design in spacesuits, also called extravehicular mobility units. A portable life support system was worn on the back, eliminating the need for a lifeline connected to the orbiter. These suits are not custom built for each astronaut. Tops and bottoms of different sizes can be mixed. They are also more flexible than previous spacesuits. The crew removed tools from a storage locker in the front part of the payload bay.
Hooked on the door here, Connie. You want me just to leave it there? That's the inner hatch. I think it's a fine place to leave it. All right, I shall.
Then moved aft again. Using a cable run through a winch mounted on the bulkhead, then tied to the cradle that had held the IUS, the astronauts demonstrated they could have lowered the cradle manually had commands from on board failed.
There is Velcro here over the outer hatch. That's what I'm going to do, sorry. Velcro in the inner hatch over there. The Velcro, I'm afraid I'll kick it loose.
Winch operations were tested on the front bulkhead using an exergenie as a load to see how many pounds the winch and line could handle.
The back pocket. Okay, I'll try that.
Lastly, the tools were re-stowed, and the astronauts re-entered the spacecraft.
Indian Ocean for 2.5.
Perhaps the most visually spectacular mission since America's first landing on the moon, Shuttle Flight 7 gave us our first glimpse of the orbiter from a distance.
Another space first.
John, we have had one more of those intermittent dropouts, but the spas came right back up and no other problems.
Thank you.
The magnificent views were provided by a European payload called SPAS.
We switched over to a view looking at spas.
We copy?
Roger that.
SPAS is an acronym for Shuttle Pallet Satellite, a unique, reusable space platform built by the West German aerospace company Messerschmitt Balkov Blom, with generous financial assistance from the West German Federal Ministry of Research and Technology.
Best wishes to those folks from MBB who built this spacecraft. It's a real
In addition to having American television and film cameras mounted on SPAS, 10 experiments belonging to the West German government, the European Space Agency, and NASA were on the platform. MBB wanted to validate the satellite's design and prove experiments could be operated while SPAS was free-flying. NASA wanted to show the remote manipulator system could handle the 2.5-ton payload.
And TJ, we just turned on the mass spec to warm it up. I assume that you wanted us to do that.
Affirmative, Sally. Thank you.
Okay, TJ, we're with you, and John performed a beautiful release.
Wonderful, wonderful.
The orbiter's ability to station keep with SPAS was also demonstrated. At this point, they are 1,000 feet apart. Here, SPAS and Challenger are 200 feet apart. Thrusters on board the orbiter were fired to record the effect on SPAS.
I could not get the spas right now.
SPAS was rebirthed for return to Earth.
They sure are nice. I've been told that some crews in the past have announced that we deliver. Well, from Flight 7, we pick up and deliver.
We certainly hope so.
The remark by Shuttle Flight 7's commander meant not only had the SPAS operation been successful, but that the crew also deployed 2 communication satellites. A Canadian satellite to be used for one of the world's first direct-to-home pay TV services, and an Indonesian satellite. It would increase high-speed data transmission and telecommunications service to that country's remote island locations.
Roger, the weather at KSC is getting worse instead of getting better, so it looks like we're a no-go for KSC.
Shuttle Flight 7 was to be the first landing of an orbiter at Kennedy Space Center, Florida. But bad weather conditions did not allow it. Challenger would touch down instead at Edwards Air Force Base, California, the alternate landing site.
Roger.
During the period of communications blackout, usually lasting about 15 minutes, temperatures on the vehicle's surface reach their peak. The temperature of the red-hot glow seen through Challenger's front windows was about 2,400 degrees Fahrenheit. One astronaut described the view as like being inside a furnace.
Processing Western Test Range data.
Houston, Challenger, loud and clear. Nice and smooth all the way down.
Real good, Crip.
Been running about 5 to 7 tenths aileron trim on the right.
Roger, we see that.
I'll say once more, we're way to come to California.
Roger that. Challenger, Houston, rolling off the hack. Your energy looks good.
Look at that thing.
180 at 10.
Oh, it's still cool, man. Look at her come in. Come on now. Come on, you big, beautiful bird. Damn, man. That's freaking awesome. Freaking badass, man.
Houston, Challenger is with
Beast.
Roger, we see that. Congratulations, a great looking landing.
Roger that.
No, the shuttle's a drone. Obviously been out of time. Can I just
Appro-
Your energy looks good. Surface wind 180 at 10.
look at this thing fall. Damn, dude. She's a beast. Come on, Crip. Nail that landing, dude. Oh, that's so cool. I miss that thing so much, dude. That's buttery smooth right there. Buttery smooth.
Houston, Challenger is with
That's cool, man. That never,
Roger, we
dude.
see that. Congratulations,
At
a
least we
great
still
looking
had
landing.
it.
Roger that.
Especially that one. Salt Flats? No, that was Edwards. Edwards Air Force Base. Yep, that was the shuttle's first landing site. That's where all the first missions came back because the dry lake bed is a very long runway. That runway is still there. I'll show you where it is if you really want to know. Boop. Yeah, Big Zig, me too. I've been there, Grav, believe it or not. I've seen that dry lake bed with my own eyes, which is actually pretty cool. Edwards is up here. So, the runway that the shuttle came in on is this one. Well, actually, hold on. No, let me look at the map one more time. They showed the map right when it was coming in. Let me take a look.
Roger, we see that.
Oh, nope. Heading alignment. So that's a 270 degree heading alignment. That's this runway right here. This boy. That long runway. This guy. Yeah. Look at the distance. That's why they use Rogers Dry Lake Bed. That's why they do this. Because you have a 30,000 foot runway. So in case there was something wrong with the shuttle's brakes or something, it'll just skid. Is Jeb in space going in your mission control? Maybe. I'll think about it. Yep. That's the one that some of the early shuttle missions landed on. And then after that, they started landing it on this runway right here. This guy. That's a... Yeah, actually, let's go threshold to threshold. There's a displaced threshold on this one, on this side. I think this is a 15,000 foot runway. Yep. 15,000. So, Edwards, for the people that don't know, there's a huge NASA facility. That's all these buildings up here. NASA Armstrong is there. That's where they do aerodynamic research. Or aerodynamic research and testing. But NASA does aerodynamic testing up here. That's all these buildings. This is NASA Armstrong right here. The Air Force is down here. And the Air Force does all kinds of stuff up in here. This is basically their R&D test pilot school. This is where they take planes and they do dumb things to them and they fly them around to see what happens. Not dumb things, but you get the idea. Like, look, there's all kinds of stuff usually at Edwards. Check that out. An A7, F-111, C-135s, a Saberliner, B-57, DC-3, C-141, B-1, C-130, Rutan plane. There's all kinds of stuff out there. I'm not entirely sure they use those. Especially the C-141. That plane was retired in the 90s, and the F-111. And there's the C-47 right there, too, and a WB-57. Actually, that's not a WB, that's just a B-57. Could be an RB-57 as well. But the Saberliner, that's a really rare plane. This picture is from 85? No. No. This picture is from 85. That one is 2018. Yep. And then there's some stuff up on the NASA side of things, guys, that you might recognize them. Like that, or those. All of NASA's R&D, aerodynamic R&D planes are up here. It's not an X-1 Smirks, it's like the one that came after that. You got an F-104, Grumman X-29, an F-8. I forget what that plane is. There's the plane that should just be set on fire, and then there's the plane that did set itself on fire. We're looking at runways again, eh? Yeah. And then there's some stuff over here that, yeah. There's a NASA F-18 right there, and then a NASA Global Hawk, which is a high-altitude reconnaissance drone. And then up here is where the good stuff is. Yeah. Yeah, you might recognize those. I have no idea how they got there. I'm not sure if that's a YF-12, Ted. Maybe. There's the 4 segments. And actually, those SRBs, that's actually a good point to pivot over to space news, guys. I've been collecting space news over the last couple of days. And those SRBs are actually something that has to do with some of the space news. So, check this out. We'll get into space news now. And that was We Deliver, the documentary there. Let me back out of here. And so let me start transferring links over. Those SRBs, I actually figured out what those, well, not figured out. We know what those belong to. We figured it out. Well, it's not that it wasn't known, I suppose. There's a good thing on Starliner aero skirts right there. That's pretty cool. What's this one? Oh, geez. We got a nice cursed rocket image for the day, which is always good. Got some updates from Blue Origin here. And then got a nice article right there. And then from a little bit earlier in the week, there's NASA's Appendix N update. And this is what I've been kind of saving on tap for you guys. Is a space-related YouTube URL okay? Of course. Yeah, Genuber. Yeah, that's fine. All right, so those SRBs in Google Earth. Those are spares that are left over from the shuttle program. Those are real shuttle solid rocket boosters. They're 4 segments. All right? All right. Before we get into the 4 segment stuff, I'll just show you this. So, Starliner did dock. We watched it dock, and the hatch opening ceremony was about 4 hours ago. They opened the hatch, and what did they open the hatch to? What did they open the hatch to find as their 0G indicator next to Rosie? Jeb. Jeb was riding right seat on Starliner. "3D printing in vacuum." Oh, that's cool. Oh, wow. I'll have to check that out. So next to the anthropomorphic test device, the commander of the mission, known as Rosie, it's the same type of test device that they use for crash test dummies in cars, but Rosie is certainly no dummy. So they have the test device, and then Jeb. That's right. There is a Kerbal in space right now. All right. Jeb is in space, man. That's so funny, man. I love it. I love every second of that. That's hilarious. Is he staying up there? Oh, I don't know. He's the zero-G indicator, so he should come back down with the capsule. But Boeing straight up, like, here, look.
This new spacecraft.
Check it out.
And station Starliner Capcom. Thanks for the great look inside this new spacecraft. Starliner team is glad to have come on board. The journey has been hard, but the reward is what we see today as our teams work together to meet the promise of advancement offered in low Earth orbit. This connection is the first of many that will continue for years to come. No one goes to space alone, and we can all benefit from the efforts involved.
It's well said, man.
Station, this is Houston ACR. Thank you. That concludes our event. Thank you. That concludes our...
Cool. So yeah, Jeb's just floating around up in space. Yep. That is the coolest thing I've ever seen, man. I can't believe that. Talk about life imitating art. And it's funny, though, because, check this out. Daz and I were talking about this yesterday on the Twitterers. And, look, Daz said, good grief, did they borrow the SAS code from KSP when Starliner was doing an inbound maneuver yesterday? Right? There it is, maneuvering into position, right? There it is, maneuvering into position. And then I said, it's kind of crazy how life imitates art. Well, geez, little did I know who was at the damn controls. It makes a lot more sense now. It makes a lot more sense, you know. Yeah, Brent said it right. It makes a lot more sense knowing Jeb was on board. That's why the RCS and the SAS were on at the same time. It's perfect. It was Jeb all along. That makes perfect sense to me. It's fine. We only have limited fuel. Can you believe that? Can you believe that? That is... Huh. That's something. So... Actually, if you missed it, we do have some NASA B-roll footage of certain events during the OFT2 mission thus far. You might want to check them out here. Take a look. How about these ones? Here, let's take a look. Let's see what we can see. Why don't we take a look?
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, and liftoff. Starliner is headed back to space on the shoulders of Atlas, powered by a workforce dedicated to its success.
I'm gonna go over here for this shot so you guys can see the counter. Not bad. Not bad.
We have confirmation of a good MET epic timer on Starliner.
Yeah, he overclocked the SRBs. That's why they overperformed. Yep.
Throttling down to maintain acceptable dynamic pressure on the vehicle.
on board today.
Yeah, please. That is what it looks like, isn't it?
This is the first plan
Nice
throttle
shot.
down for Atlas in preparation for Max Q.
Max Q, maximum dynamic pressure on the vehicle.
Right now, atmospheric forces are the highest Starliner Atlas will face
Oh,
during the
wow.
uphill climb.
Are these GEMs or casters? Neither.
Mach 1, Atlas 5 and Starliner are now supersonic.
They're AJ60As on this particular version of Atlas because those.
Up next in about 20 seconds,
responses looking
Starliner's 2 solid rocket boosters will run out of fuel and burn out.
Because those SRBs are the ones that are human rated for now. What issues did they have with Starliner? On this one, just a couple of hiccups here and there. No issues. The mission is nothing mission critical. Just a couple of small things here and there. You know how I know? Because it's at the space station.
We have burnout on both SRBs.
Jeb is on that,
Module forward
by the
link
way.
connection.
Jeb's
RJ
on
is
that.
throttling back up to full thrust.
Jeb is on that freaking. Wow, this track
Now that
though.
we pass the solid rocket booster burnout, you'll soon see those 2 solid rocket boosters separate from the vehicle.
You don't know how hard that is to do that far away. That's a damn good track for what it is.
8,
Here, let's
7,
go to the next view.
6, 5.
Sorry, it was your first time operating the camera.
3,
Oh yeah?
2, 1, and liftoff.
Burb.
Starliner is headed back to space on the shoulders of Atlas, powered by a workforce dedicated to its success.
Oh, that's just fantastic. Jeb is on that, man. Dude, I can't believe that. Wait, what's up, man? 8313 sub. Wait, did you see who was riding right seat on this? Seriously.
MET epic timer on
Look. It's right here. Look who's riding right seat. Not making that up. Jeb's riding right seat, man. I can't believe that.
This is the first plan throttle down for Atlas in preparation for Max Q.
Max Q, maximum dynamic pressure.
That's right,
on the vehicle.
Pigzig. Yeah. Atlas has not moved people. An Atlas rocket has not moved a person into space since 1962. I wonder how they got Jeb on board. NASA said that the Starliner engineers put him on there because they were all Kerbal players that are working on Starliner now. True story. Can you believe that?
Vehicle now throttling up.
Up next in about 20 seconds, Starliner's 2 solid rocket boosters will run out of fuel and burn out.
It is, Christian. Jeb is on board. Jeb's on board. He's on that thing. Look. Boeing even tweeted it out. Look at it. Boeing tweeted. What is happening? I don't. Look. Has squad responded yet? Of course they did. Here, let's see. That's just strange. That's just strange. Jeb's riding right seat. Look, Sergei Korsakov took this picture. Look. What in the frick? You believe that? Aluminum tubes!
Rocket boosters.
Here, let's check out some more of these camera views from the OFT2 launch.
5, 4, 3, 2, 1.
Yeah,
And
yeah,
liftoff.
Crash. Mhm.
Starliner is headed back to space on the shoulders of Atlas, powered by a workforce
I know,
dedicated
Ian.
to its
Someone's
success.
just got to do that. Jeb was the pilot on the mission. Jeb's the pilot. Rosie is the commander. That's so funny, dude.
We have confirmation of a good MET epic timer.
Time
on
flies,
site.
RJ. Does that mean Jeb's 1 star in real life now?
For Atlas in preparation for
Or-
Max Q.
Yeah, let's see what other shots we have. Wow, that track goes real far. Ooh.
9,
Ooh, what's
8,
this?
7, 6, 5, 4, 3, 2, 1, and liftoff.
I agree, Pigsig.
Starliner is headed back to space on the shoulders of Atlas, followed by a workforce
What a
headed
shot!
to its success.
I like that. Yee! That's nice. That's pretty neat.
We have
Look at the
confirmation
roll.
of a good
Oh,
MT
that's
at
so
the timer on
cool.
Starliner.
Atlas executed its roll program.
Already ready. He's now
Engine
throttling down to
attitude, put the
maintain
crew in a
acceptable
heads-up
dynamic
position.
pressure
We
on
had
the
crew on
vehicle.
board today.
Wow.
This is the first planned throttle down for Atlas in preparation for max Q.
Max Q, maximum dynamic pressure on the vehicle.
Right now, atmospheric forces are the highest Starliner Atlas will face during the uphill climb.
Mach 1, Atlas 5 and Starliner are now.
I'm sorry, I didn't see. I always talk about
Vehicle now.
I always talk about times where you know you don't need to say anything. You don't need to fill dead air. No, Pi, they do not. The RD-180 is doing the gimbaling on this version of Atlas. RD-180 has 8 degrees of gimbal, believe it or not, and it can each nozzle can go 8 degrees out in either direction. So it can do it can do this, or it can do that, or it can do that, or it can do that. It can do that. It can go out. One side can stay straight, the other one can turn, or it can do that. It's pretty freaking cool, man. It's a pretty cool motor. The 2 nozzles can go in all different directions. Right, Jonas? Yeah, man. That was probably a good idea. Yeah. I just wish Europe had one. Yeah. Hopefully you guys pull your head out of your culo soon.
Atlas 5
Or you can just ride on our stuff. That works too. You have all right, Jonas. Let's put it to you like this: you have half of a spacecraft, all right? Because the Europeans made half of the Orion. So actually, the Germans did. The Germans made that service module. All right, so you have half of a spaceship. We'll half. That's fine. Is it just me, or did they step up their game with launch footage? I think guys, this is using a lot more shuttle resources than I thought. Starliner is, like, I know Boeing says, like, oh, this is not just shuttle in capsule form, but it really is. Like, the Starliner mission was using a shuttle flight control room at Johnson Space Center. Starliner itself is made up of shuttle parts. We know from the valves, the thermal protection system, the tiles. I looked at the control systems. The control systems seem to be derived from the shuttle as much as you can. I mean, pods and shuttles are 2 different things, but it's kind of cool. Dude, even down to the ascent. The ascent profile mimics the shuttle's ascent profile almost perfectly. The Atlas core stage goes a little bit further, right? But if you think of like Atlas 5 with Starliner at the top, and then you think about the shuttle, so you have 2 solid rocket boosters, but you have a core stage too. So the core stage and the SRBs work like the SRMs on Atlas work like the SRBs. And then the Centaur, the dual engine Centaur, is a Hydrolox upper stage. And the Centaur's ascent pattern, I look at it. It mirrors the external tank. It's flying on the exact trajectory that the external tank took. So it burns up in the Indian Ocean. It's a one and done. So it doesn't even get into orbit. And then the capsule uses its onboards to circularize, right? Just like the shuttle would use its own thrusters to circularize. Heck, the thrusters are almost called the exact same thing. On the shuttle, they were orbiter maneuvering system. And then on Starliner, they're orbital maneuvering and control systems. OMAC thrusters. It's almost the exact same thing, which is actually really cool. It's actually pretty neat. Have you watched the Starliner tour video? Nope. Can't believe Atlas 5 is crew rated without any crew mission. Yeah, imagine human rating a rocket and then never using it to launch people. Who would do that?
Atlas.
Ooh, infrared.
9, 8,
At least
7,
it looks like it.
6,
No, it's not infrared. It's
5, 4, 3, 2, 1, And liftoff.
I love that noise.
Starliner is headed back to space on the shoulders of Atlas, powered by a workforce dedicated to its success.
Oh, yeah, that maybe it is infrared.
We have confirmation of a good
I don't
imaging
hate what
method for
I don't hate what I
Starliner.
see here.
About 20 seconds. Starliner's 2 solid rocket.
Mach 1, Atlas 5 and Starliner are now supersonic. Vehicle now
What a
throttling
shot.
Up next in about 20 seconds, Starliner's 2 solid rocket boosters will run out of fuel and burn out.
Even hearing the old shuttle commentators, man, it makes me so happy. That's so cool. Why does the rocket turn? Well, Dumpster Dog, this gets a little bit weird. The rocket turns, like you're talking about the roll program. That's what it's called. The roll program establishes the proper flight azimuths for proper orbital insertion at the right inclination. If that made no freaking sense, basically some orbits are tilted. So like if you look at Earth, right, and you draw a straight line through the Earth, that's the equator, right? You have the top hemisphere, the northern and the southern hemisphere, right? If you draw orbits relative to the equator, the angle that the orbit has over the equator is what's called orbital inclination. So it's a tilted orbit, right? The ISS is in a very tilted orbit. It's 51.6 degrees inclined off the equator, meaning it's 50 degrees tilted comparatively to the equator. The rocket, when it launches, it needs to turn. It needs to turn so it goes in the right direction, because you don't want to kind of launch it and then fly like kind of sideways, right? It's important to orient the vehicle, right, to... You can some crew vehicles fly upside down into space, like the shuttle. The shuttle will fly upside down. Starliner's probably flying upside down too, so they have to turn. They turn to get the right vehicle orientation. There's a couple of reasons why they do this. For the shuttle, they did it so the astronauts can see the ground. The pilot can actually see the ground for better spatial orientation. That's probably why Apollo flew upside down into space. Starliner does. I'm not sure if Dragon does. Probably. It's so you can look out the windows and see the ground. But the reason why it does that turn is because of different orbital inclination. Yeah, it just turns to go in the right direction because you kind of want to orient yourself relative to the horizon. It's easier for people on board to figure out where the heck they are. Also because negative G's are bad. English, Doc! Yeah, right. Would the solar panels on the back instead of the sides, Dragon, be more demanding with keeping it oriented correctly for recharging? No. No, Sile, not really. It really doesn't matter where you put the solar panels. Yeah. So, yeah, that's why... That was actually a super good question, Dumpster Dog. That's why you see the thing do this whole roll program. Now, if you're wondering... Okay, so why don't they just turn... I know the next question. I've answered this question a bunch of times, dude. The next question is, okay, so why don't they just turn the rocket on the pad? Some rockets do that. Some rockets just use the engines, the thrust vectoring on the engines, and make one engine go this way and make the other engine go this way, and the whole vehicle turns right after liftoff. Some do that. Soyuz has a turnable pad. The pad is actually on a gigantic turntable, like a record. And they could just turn the rocket and then shoot it off in a different direction. Does GPS work on the ISS? It can, Long Eye, but they're not really using GPS. They use NASA's tracking system, the tracking data and relay system. They use TDRS. It's a little bit different. GPS is in a semi-synchronous orbit. TDRS is in a geosynchronous orbit. So what's the difference? Semi-synchronous has an orbital period, so the time it takes to do one revolution, at about 12 hours. Geosynchronous has its orbital period at 24 hours. The geosynchronous one, because the RPM, the revolution per minute on the satellite to do one orbit is synced with Earth's rotation, right? So the geosynchronous satellites appear to just kind of move with Earth, right? The semi-synchronous ones, like what GPS is, where the global positioning satellites are half of that distance, half of the orbital period, so they do 2 revolutions per minute per day. You could use them, sure. They're both well above the ISS. So geosynchronous is like 23,000 miles that way. Like straight up. Semisynchronous is 12,000 miles that way. The ISS is 270 miles that way. So you could use it. It depends on the system. Sure, why not? But see, this gets a little bit complicated. So why does it get why does it get complicated? So if you know, this comes down to context for engineering, right? Long Eye, you probably heard me ranting about this the other day. I saw you in chat. Thanks for coming back, by the way. Right on. Space is dope, right? So this gets a little bit complicated. If you're designing something just to go to low Earth orbit, then you can use something like GPS. But what happens if you send a capsule out to the moon? Now what? You're above the GPS. The GPS only goes in one direction. It only goes down. So does TDRS. So some capsules can use GPS. Some of them really shouldn't. Like Orion, for instance. That probably, yeah, you probably shouldn't do that. Because once it gets past 12,000 miles up, like if it's going to the moon, then it's pretty useless. That's probably not a good idea, right? Here. But yeah, good questions, dudes. This is great footage. I like this one.
Starliner is headed back to space on the shoulders of Atlas.
Yeah, watch.
Workforce
Let's see.
dedicated to its success.
I'm wondering if we could see the RD-180s do the twist. Because the solid rocket motors on the side, the SRMs, those have a fixed nozzle. The nozzle doesn't move. It's the center, it's the ones on the big center booster there. The Atlas CCB is what it's called. Those are the nozzles that can turn. I'm wondering if we could see it. Nah, it's hard to see.
Discovery, go and throttle up.
So there you go. There's your induced roll. See? The whole thing is turning to go in the right
We
direction.
have confirmation of a good MET epic timer on Starliner.
Oh, hey, Battle Rock. What's going on? Oh, that's so freaking rad, man.
Atlas executed its roll program.
Scarfed nozzles? What do you mean, Stealthy?
Heads up position. She had crew on board today.
That's nice.
This is the first planned throttle down for Atlas in preparation for...
Are there SRBs that do gimbal? Sure, Nor. Yeah, those ones right there do. Yep. Space Shuttle. The Space Shuttle SRB's gimbal. Now, I know what you're asking. Well, why? What do you mean? Don't the Space Shuttle engines do the steering? No, not when the SRBs are attached. No, the shuttle engines kind of just stay fixed. All they're doing, like on the shuttle, for instance, all those the main engines are doing are just holding the shuttle in place, making sure that it doesn't go this way or that way. Because turns out when you attach like a 60-ton brick to the side of your rocket, you need some rockets behind it to get it to fly on an even keel. If the shuttle engines are too busy keeping the stack pointed in the right direction, the SRBs on the shuttle are used for steering. Because they're doing 80% of the work. The SRB nozzles on these 4-segs that were on the shuttle, the 4-segment boosters, they can gimbal 8 degrees as well. Yeah, 8 degrees. And they're doing the majority of the steering, or, well, not the majority, they're doing all of the steering when they're attached. When they detached, that's when the shuttle engines start moving around. Are those solid rocket motors able to cut off in an abort? The launch escape system will be able to get away from the stack, Slayer. Yep. They have a termination system on them. So, yes, they can shut them off. And the way they shut them off is blowing them up. Hey, it shut it off, didn't it? It shut it off. I mean, you didn't ask if there was going to be an SRB left, and I'm pretty sure if they went into an abort, making sure that the SRBs are still in one piece is probably the least of your concerns. Am I right? Like, that's what it seems like to me. Actually, you want to know a good termination system for SRBs? So an SRB is just a pipe with a nozzle at the end. It's just a big Estes rocket motor. Like the Estes rocket motors are model rockets. Those are SRBs. Straight up. That's what they are. They're a solid rocket motor. The ones that NASA uses are just segmented ones. It would be like taking Estes motors, and please, for the love of God, do not do this. It'd be like taking Estes motors and stacking them on top of each other. That's literally what they do. Do not do that. You will hurt yourself. just saying. Just This is for visualization only. Don't do that unless if you value all your digits, right? Keeson's like, Peepo G. Now, you can turn the SRBs off. Other SRBs are what's called a solid casing SRB, where it's just literally one segment with a nozzle at the end. You want to know how you get them to shut off? Pop the top off. Simple as that. Pop the top. If you pop the top off, you have pressure going out the top of the SRB and pressure out the bottom, and you'll make no combustion chamber pressure at all. You literally just poke a hole in the SRB and it'll shut off. Or there's another way that you could do it by inerting the SRB. Inerting the SRB will, like if they pump inert gas into it, they purge it out. So like you have an abort system that has like a CO2 tank, for instance, and you shoot CO2 into the SRB's combustion chamber, and it basically blows out the fire. Nerding the SRB? I mean, no, nerds designed this. It is already nerded, okay? Yeah, so you could pop the top of the SRB like a Pringles can, but in a launch escape scenario, right, if the capsule's up here, you don't want to pop the top off of the SRBs because then fire shoots towards the capsule. Probably don't want that. That seems like the engineers are not good at dealing with customers. Capsules are only so good at dealing with fire. Yep. And the fire has to come from one direction. That's really important. Inerting was what the ASRBs were going to do. There's plenty of ways to shut them off. The ASRBs would have had a purging system. Yeah. I think they wanted to purge it with inert gas. I think they wanted to do the second one. But I'll be honest with you, you could just intentionally blow the O-rings on the SRBs and that would shut them off. But that probably is not a good idea. Let's be real. That's probably not a good way to do that. Considering, it's probably not a good idea. I don't know, Flacken. I don't think so. I mean, the pop the top system is probably not the best idea because you'd have to like poke a hole in the side of it, and that's basically what an SRB termination system is. It's just det cord down the side, and it blows a hole. It unzips the SRB, and the thing you lose chamber pressure immediately, and the thing just shuts off. I mean, it's also destroyed, but if you wanted to destroy it, there's probably a good reason. You're probably not worried about it coming back. That's for sure. So, anyway. Yeah, I mean, you guys you could pump inert gas into the SRB if you really want to. Speaking of blowing O-rings, would you mind explaining what happened on Challenger? I don't really know that much about it. Crustacean, Challenger is a project management problem. It's a problem that was plaguing the entire space shuttle program, basically from the start in 1972 all the way to 1986. What do I mean? The short story is this. I'm going to say this fast. Challenger had a problem with the O-rings not working in cold temperatures because we have segmented SRBs. You have 1 segment, 2 segment, 3 segment, 4 segment. They ship the SRBs in pieces because, one, SRBs are extremely freaking heavy. The solid rocket propellant is super dense. It's also super energetic. It's carrying a ton of potential energy. And that makes it super freaking heavy. I mean, it does move the tank and the shuttle up into space. Those aren't light, right? So they bolt them together, and then there's O-rings inside to make sure that the SRB seals and the fire doesn't come out the side, it comes out the bottom. In cold temperatures, they weren't working. They weren't working correctly. There was also kind of a little bit of a problem with how the SRBs were joined together. Basically, they joined them in a way where the flanges would expand and fire would get to the O-rings, which you really didn't want. You don't want to light your O-rings on fire, right? Now the O-rings would heat up and they would seal if it was warm out, right? But if it was cold, the O-rings would become brittle, and there's 2 of them in double redundancy, right? And if both of them are brittle, the fire will just blow through it and come out the side of the segment where the two segments are connected, right? Now, here's what I mean about project management problems. Somebody at NASA looked at that and said, oh, sweet. You mean the O-ring fails and... Oh, the O-ring fails and fire comes out the side. Well, that's not good, is it? And then somebody else at NASA said, no, it's all right. Well, why is it all right? They looked at that and saw that the fire coming out the side of the SRB, this was tested. This showed up in testing and on previous shuttle flights, too. That the fire jetting through the two flanges of the SRBs, the fire going through it, would actually weld the two segments together. It would weld them together because the gases in the SRB were so hot, it would melt the metal and the metal would fuse between the two segments. Somebody at NASA looked at that and said, hey, look, it's extra safe now. Look, even if our two O-rings fail, it'll weld itself together. It's triple redundant now. We didn't engineer it to be triple redundant, but it's triple redundant now. Yeah. If that sounds as dumb as it is, that's, you know what? I'm not even trying to. That's the stupidest thing I've ever heard. This is why I always talk about crustacean. I always talk about understanding what the frick you made. Okay, this isn't Kerbal. I mean, it is now because Jeb's on Starliner. That's pretty cool. But you don't look at it and say, "Oh wow, it did this unintended thing oh wow, I wanted it to go up and it went to the left. Wow, that's cool." No. That wrong scientific method for aerospace engineering. That's not how you do that. When you do aerospace engineering and testing, you have an analysis. And then you go test your analysis, and if those line up, then you're good. If they don't line up, then you're not good. This is what I mean about project management. That's somehow somebody looked at that. Oh, the O-rings fail catastrophically. They fail catastrophically, and the segments weld themselves. That's triple redundant now. Triple redundant, baby. So they just said, it's fine. Just keep flying it. It's fine. Just keep flying it. They had multiple flights where the O-rings failed completely and the segments welded themselves together, and they were just like, that's cool. It's fine. Enter Challenger 51L. It's too cold. It's too cold on January 28th, 1986. Way too freaking cold. Way too cold. Now, the shuttle had multiple launch constraint violations. It was way too cold to launch it because they didn't want to toast the O-rings, right? And it was also too windy. Not a lot of people know that, and not a lot of people dwell on this. But if you go read the Rogers Commission is the Challenger accident investigation. It was written by a guy you might know, Neil Armstrong, wrote it. Yeah, and Sally Ride. Those are two. Yeah, those two. Yeah, whatever they have to say or have said in the past, I usually listen to them. They know what they're talking about. So they had not one launch constraint violation, but two. Upper level winds were way too high. They were way too high. The shuttle's not very aerodynamic, and winds up there are a real big problem. Why are they a big problem? Well, the pressure is less up there, right? You go up there, there's not enough air to breathe, and the shuttle's going to get up there very quickly. Upper level winds, because the pressure is lower, allow for a much higher airspeed. The winds up there are like 300-400 miles an hour. Now, don't get me wrong, you're not getting hit with as much air molecules because the pressure is lower, but you're getting hit with more molecules faster. The wind blows a lot harder up there. Anybody that's ever been to the top of Mount Everest, or if you've seen footage from the top of Everest, you know what I'm talking about. It's very windy. The shuttle's not very aerodynamic, and it's by the time it gets up there, it's going like 2,000 to 3,000 miles an hour, and it's going to get hit with 300, 400, 500 mile an hour winds, and that causes what's called wind shear. Your rocket's going this way, your wind's going that way. You create a shearing force on the vehicle. The upper level wind constraints for 51L were not good. There were two violations that day. They were way out of spec. But some dingbat at NASA said, this is a really high profile launch. We really shouldn't scrub today. No, we shouldn't scrub. You know, we have to make sure we launch the shuttle today. We have to launch. Go. That phenomenon of getting complacent and impatient with your spaceflight is called, well, go fever. So, they go to launch. The O-rings fail instantly on the pad. Instantly. I'm not showing the footage. I won't do it. I can't do it. I'm not doing that. You go watch the footage. The O-rings fail instantly. The place where they failed was right where the fourth segment SRB connects to the external tank. So between the third and fourth segment, that's where the strut is on the back of the external tank. There wasn't one. There wasn't a NASA administrator when STS-51L launched. Funny story. So, you go to launch. O-ring fails. It seals, just like they thought it would. But you got to remember, this is new behavior that hasn't been tested on the vehicle. This is why testing is so important. They launched it, O-ring failed. That's observed behavior. That's happened before. Challenger goes. It makes it right off the pad. If the O-rings failed completely, it could have blown up right on the pad, but it didn't. It did what they expected it was going to do. Launches. Shuttle gets to maximum dynamic pressure, starts throttling up. They throttle up the main engines. The SRBs are using at that point in the ascent regime, they're on a progressive thrust curve, and then they go to regressive thrust curve after maximum dynamic pressure. So the SRBs start kicking it into overdrive. They throttle the shuttle engines up. 73 seconds comes in. Challenger gets hit by the biggest wind shear ever recorded ever on any vehicle launching at KSC ever. They got hit with like a 500-mile-an-hour wind shear. Most of the shuttle stack was fine, except for that failed SRB segment. This is why testing is important, because they tested the SRB segments on operational missions, literally rolling the dice with crew lives, which is the dumbest thing I've ever heard in my life. Like, I don't know how you can be that stupid, but I'll get to that in a second. So, whole stack gets hit by a wind shear. The back segment gets hit by that wind shear, and it's just melded together. It's like molten metal because the SRB is still on. And the fourth segment does this. The entire fourth segment starts to buckle. It starts to buckle. So the nozzle starts pointing like this. If these are the two SRBs, the nozzle starts pointing out. That puts on the aft external tank attachment point, which is designed for up and down force, it puts sideways force on it. That fails. And then the right SRB just goes into the external tank. That's it. Game over. That's the end of that. The external tank pressure vessel fails. The whole shuttle blows up. You get a catastrophic unplanned disassembly, and that's the end of that. The SRBs ironically keep going. So, we all know what happened after that. Not cool. It's sad. It's really stupid. It's really stupid when you think about it. They broke every freaking rule in the book. Every rule. Everything that they learned in the Apollo program. They threw that out the window and said, screw it, let's go anyway. Now, here's the thing. Okay? There are two underlying things, and this is the second part of, believe it or not, this is the short story. This is the short way of explaining this, Crustacean. I have a much longer way of explaining it, but why was there no way for the shuttle to disconnect from the stack in an emergency? The shuttle was designed like an airplane, Crustacean. That was the intention. The expectation was that you didn't need a launch escape system because you would launch so much you would understand your vehicle. They would be able to understand the vehicle correctly, and the SRBs wouldn't fail, right? Don't think of the shuttle like a rocket. Don't think of it like a Saturn V. It's not a Saturn V. It's a space shuttle. It's different. So think about it like an airplane. Does a 737 have ejector seats? Does a 737 have an escape system? No. They were trying to make an airplane that flies into space, right? That's why it didn't have an abort system. And the thought was that the SRBs were so ridiculously simple that it's very unlikely to have a problem from them. Which brings me to this next part. Now, first and foremost, a little while ago, I did a study. I did a study into NASA's early funding numbers, basically Mercury, Gemini, Apollo to the shuttle, right? So NASA's funding basically from 1958 to 1975, somewhere around there. It was based off of a paper that I read about Apollo funding and how proper space program funding works. That paper's still around somewhere. I looked at it off stream and I started crunching some numbers, okay? Started crunching some numbers. So the numbers that I crunched basically state this. And I'll have to write this up in a paper or something to present my findings correctly, but okay. I'm going to show you two pictures, okay? I'm going to show you two pictures. They're both nice pictures. So the first one is that, right? Shuttle, you know. Nice. I like that. It's a good picture. Second one is this. Anybody know what that is? Alucard, Popsicle, how you guys doing? That's Titan. What's it launching? That's a Titan II. Specifically, that's a Titan II GLV. So what's this up here? GLV stands for Gemini Launch Vehicle. So that's a Gemini program. The Gemini program used a Titan II and a Gemini capsule that was designed by a guy named Max Fizet. Max Fizet also designed the Apollo capsule and the Mercury capsule and contributed significantly on the space shuttle's design as well. Now, which one of these vehicles looks more complicated? You tell me. I'll just keep going back and forth. Which one of those looks more complicated? The shuttle for sure. Crustacean, NASA developed the shuttle with the same budget adjusted for inflation as the Gemini program. That is a glaring problem. In my mind, at least. Literally, both of these rockets were developed for pretty much the same amount of cash, adjusted for inflation, because this was the early 1960s and this was the early 1970s. They developed that for the price of that. So, that's the first problem. That's the first glaring problem in my mind. Challenger was just a matter of time. It would have happened if Challenger didn't go that day and they waited the next day and they still had SRB blow by, another mission would have failed. There's just no way. Another mission would have had a problem. Now, the shuttle's way more complicated than the Gemini program, isn't it? The Gemini program is just a capsule on a Titan II missile. It's literally just a slightly modified version. Slightly modified version of a Titan II. The SM68? 68 is Titan, I think. So, underfunding. You don't make the most complicated launch vehicle ever devised by man that's partially reusable for the price of this. That is the stupidest thing I've ever heard in my life. But that's what they did. They cut the Apollo program, and the Gemini program had concluded, and they picked up the scraps and pieces of funding from the Apollo program and concocted the shuttle out of that. The shuttle was consistently underfunded from 1972 when it started all the way to 1979, 1980 when they started doing operational missions, and even then it was still underfunded. Underfunding means that you're not able to do the conclusive testing that you need to fully check out a system, and they never did. They did tests with the SRBs, but the tests were not conclusive enough. Simultaneously at the same time, and this is the second part. NASA got gutted so hard that most of the experienced personnel left in the 70s. You notice how there weren't many Apollo astronauts that flew on the shuttle program? Because they said, frick this is dumb, I'm out. So, you had a huge personnel loss from the Apollo program. And that's where the project management problems start. Now, because it's ironic. Because the shuttle program was so underfunded, it was underperforming. The shuttle they shipped the shuttle in 1979 to the Cape, and then the tiles fell off. The shuttle it was supposed to fly 1978, 1979, somewhere around there. It didn't fly till 1981. He was 2 years behind schedule. And even then, NASA started accumulating huge backlogs of payloads. So there was a lot of pressure on NASA management to get it done. The problem is, when you put a lot of pressure on somebody to get something done and don't give them the tools that they need to succeed, i.e. the money that they need to sufficiently run the most complicated launch vehicle ever devised by man, you get some problems. Like, oh, the SRB O-rings aren't working correctly? Whatever, they seal themselves, it's fine, it's okay, it'll work. Look, we launched one before, it was just fine. The second part of that is that they were under extreme pressure, so they were more risk adverse or less risk adverse. And being less risk adverse when you're doing testing and rolling out and ramping up a spacecraft is a really stupid thing to do. I understand that there's a balance between deadlines and not deadlines, and you have to find the line there is kind of blurry between, doing really stupid things with rockets and being bold, like going to the moon, for instance. Apollo, we choose to go to the moon in this decade, right? There's a blurry line there, and that blurry line falls within a nominal window of, like, how willing are you to roll the dice? In NASA's case, because of underfunding and pressure, ironically from the same entity, they were under pressure to get stuff done. They were also not funded and not given the tools that they needed to succeed. So somebody had to say, yeah, it's good, we got to launch it today. What am I going to launch next month? We have to get on schedule here. There's nothing wrong with wanting to get on schedule and wanting to, play catch up, right? If you're a year behind on launches, right, you don't want to be behind. That's no good. But at the same time, if you're not given the money to launch more shuttles, how the frick are you going to do that? How are you going to catch up? And the further and further you deviate from your deadline per NASA systems engineering, the further and further you deviate, the further and further the underfunding happens. It's not like, if your nominal funding line, like what you want is here, and your funding line is here, a funding boost to get you back to that line is not going to help. You need double for every deviation away from your funding. So say NASA asks for $1 million for the shuttle, and they get $500,000. The next year they ask for $1 million again, and they get $500,000. So NASA now has like $1 million, and they needed $2 million. If you go to the next year and NASA says, okay, we're $1 million behind, that'll get us back up performing. No. You're going to need $2 million. And what is this based off of? This is based off of analyzation of past NASA projects per NASA Systems Engineering Notebook. Double the cost to get it back on schedule. You have to make up the gap and then some. You can't just make up the gap because you're already behind schedule. See what I'm talking about? That's no good. That's really not a good idea. So crustacean with the SRBs were just, it's what's called a cascading problem, a cascading failure in engineering. Congress made a compromise by funding the shuttle, then gave unrealistic deadlines for the funding. NASA tried to pursue that, and then NASA was less risk adverse. So they were willing to cut corners because they needed to perform, but they were getting underfunded. They needed to cut corners. They needed to cut a corner here. 2 O-rings is fine. The flanges blowing themselves apart, if the O-rings fail, that's fine. Whatever, it's good. Send it. Let's go. And then seeing the SRBs do something that you didn't encounter in testing, also a big problem. That's called normalization of deviance. That is very, very bad. You do not do that crap with spaceflight. If you launch the thing and it overperforms, like I guarantee you this happened with OFT-2. OFT-2, Atlas V in the N22 configuration overperformed. It did better than what they were expecting. Now you'd think that that's a good idea. That's good. All right, cool. It did better than we thought. No, that is not okay. That's not good. Why is that not good? Because even though it's doing better than you thought, that's still deviation. It's deviation in a positive trend, but that's still deviation. That's bad. That means your math is wrong. That means your initial analysis on how the vehicle will fly is wrong. That means oh, I think 2 + 2 = 4 is going to happen. And then you go to do it on a calculator, and the calculator says 2 + 2 = 5. Something doesn't add up there. That doesn't work that way, right? 2 + 2 = 5. No, that's not right. It can't be right at all. Good engineering isn't necessarily meeting above the constraint or below the constraint. There's a nominal window. There's a nominal window of what's called it's deviation. A nominal window of deviation, and how that nominal window of deviation between the line between like perfect performance, overperformance, underperformance, where that line is compounded based off of what you're doing. That it really depends on what you're doing. Sometimes you have a little more gap. Sometimes you have a little less. Like for instance, Atlas V overperformed. Who cares? That's not that. Well, not who cares. That's a good thing. It doesn't really screw you up in too much regard. Say like a rocket like the Saturn V underperformed. That means you're not getting to the moon, right? Because even a little bit of underperformance on ascent for a Saturn V is going to translate to a much bigger problem down the road. They compound. The problems can cascade, and every time you let the problems cascade, you say, it's fine. It'll get worse and 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 worse down the line. Anybody play Kerbal? You didn't get your orbital ascent right, and your second stage has to burn way more, and then for the entire rest of the mission, you're just squeezing out Delta V out of every single facet of the spacecraft until you strand Jeb in space? Exactly what I'm talking about. It's not about over or underperforming. It's about getting it as close as you possibly can to your initial analysis. Understanding what the frick you made. That's the real important part. With Challenger, they didn't even do that. They didn't have the money to. Underfunding is very bad for a program. That is very bad. Very bad. So there's your short story. That's a great picture. How many of these early shuttle launches were military missions? A good amount of them. There's the engineer's responsibility for ethics. That entails major pushback when it's needed. Yep. Does that make sense? Crustacean? That's the short story. If you want to learn more about this, you need to read the Rogers Commission. The Rogers Commission was a group of experts in the field. Neil Armstrong was on it. So was Sally Ride, the first American woman in space. They were on this committee to figure out what the frick went wrong. Basically, Neil came out of retirement and said, what the hell are you guys doing? What are you doing? This is the dumbest thing I've ever heard. Why did this even happen? And then he went and figured out why it happened. And then he promptly showed the Senate and NASA why they were stupid for what they were doing. It's pretty awesome, actually. Yeah. So under engineering, too much pressure to fix the engineering, not enough money to delay to fix the program, and too much pressure from above to keep it going. Yeah, pretty much. Compounding factors. Yep. Systems engineer who currently works on DoD contracts. Yeah, roundabout. I love systems engineering. Systems engineering is my favorite, dude. I've been diving in deep into the NASA systems engineering manual. It's really cool. Dude, if NASA just did that every time, holy crap. But sometimes you can't because you ask for $1 million. The president says you need to do this. You tell the president it's going to cost $1 million. You go to Congress, say, hey, the president wants to do this. It's going to cost $1 million. And Congress goes, okay, we'll give you $350. Oh, okay. Yes, Hank. You said there was footage where you could see the O-ring melt instantly. You see the O-ring fail instantly. It's a puff of gray smoke that comes out of the inner side of the SRB. I'm not showing it. You can go find that on your own regard. On your own time. Sorry, excuse me. Yeah. That's there's a little lesson. Crustacean, that's why I always go on things about, and that's part of the reason why I can answer the press questions so well, because all what I just told you about understanding the vehicle and how the vehicle works is like NASA's mantra. Like that every single question can trace its roots right back to that. Did you understand what the frick you just did? That's really, really important. My coworker's son is an engineer on Artemis. Cool. And you know good, well, Gav, like, it's funny. Everybody I talk to that works on the Artemis program knows this. They know it. You can't screw around with this stuff. If you screw around with this stuff, people get killed. If people get killed, you know, that calls into judgment on everything that NASA is doing. You cannot screw around with it. It has to be perfect. Just my opinion. Poor budgeting is rarely a NASA problem. I'm not exactly sure where you're going with that roundabout, but yeah. Hanky, in the the Marines, literally, underfunding and the USMC go hand in hand, dude. It's, I'm curious to see if I got it right, Joe Lucy. We always ask for twice the amount of what we needed to get half as much as what we needed. Yep, the Marines always get the shaft every single time. Let's just give our elite amphibious force less money. That's all right. These guys, are only designed to do one of the hardest things to do in freaking military tactics, which is take a beachhead. Let's just give those guys less money. It's fine. It'll be fine. Yeah, the Gaffling. Yeah, that happens. People move around in the industry all the time. There's influx everywhere. At NASA, Blue Origin, SpaceX, people just go around and around and around. The president proposes and Congress disposes. And Pigzig, that's what Bill meant when he said that to the Senate committee. That's why I was like, whoa. That's why Bill is an emote now, because that's basically what he said. Bill Nelson, the NASA administrator, the other day in a Commerce, Justice, and Science Senate committee hearing, right? Commerce, Justice, and Science Senate committee hearing. Yeah. What he said, in a nutshell, like he said, he had this is the real Southern way of doing things. If you're not from the U.S., people from the North, like where I'm from, they're like the Northeast part of the U.S., we're very straightforward. Hey, I'm walking here. Get the frick out of the way. What are you, stupid or something? Like, that's New York, but whatever. You get the idea. Like, they'll just insult you outright. People from the South have this thing of insulting you without insulting you, but making it sound like a compliment, but it's not a compliment. They're saying you're an idiot, right? So what Bill said, Bill Nelson's from Florida. He grew up on the Space Coast, interestingly enough, right? What Bill said, basically, is one of the senators, who's from New Hampshire, which is wicked funny to me, one of the senators said, why are you guys underperforming so much? Why are you underperforming so much? Why aren't you able to achieve the goals that the president wants to achieve? And Bill, if he was from the North, he basically would have said, you got to give us more money to do that there, Chief. Yeah, that would have probably been a better thing to do. If you give us that money thing that we need, to do things, then we'll actually do what you want us to do. But you don't. And then you wonder why something's going on, right? Like that would be the way I would answer that, right? Bill, little bit less candid. He goes, well, as you know, the president proposes and Congress disposes. He's basically saying what I just said. Like, look, every time we want to do something like this, you guys don't give us the freaking money to do it, and then we have these dumb freaking meetings where you ask us why it can't be done. It can't be done because you don't give us the damn money to get it done. That's what he said. And it was hilarious because there was like 15 seconds of awkward silence after that where the senator up on the stand was like, okay, like we had the all right, like it's like, yeah, you're an idiot. That's right. That's why Bill is an emote, because he insulted this person to their face, which is really funny, man. I appreciate that response. It was great. When I saw it, I'm like, no way. Wow, he just called you an idiot. That's awesome. Yeah, oh, bless your heart. Oh, you sweet summer child. Yep, no, we're not that polite down here. Or up here. We'll just say you're an idiot, Yep. Yep. She said, I appreciate that response. Hook, line, and sinker, Novus. That's the funniest thing I've ever seen, dude. Funniest thing I've seen in a Senate committee hearing. I couldn't believe it. Go back and watch the VOD. I'm sitting there going, what the frick just happened? Oh, man. I genuinely did not think he is. No, Lazarus, here's the thing. Congress is like high school, from what I've been told. You can't insult somebody. If you insult somebody, that's going to come back to bite you later because people talk. So you can't. Southern draw works in Bill's favor in this regard. Is the Pope Catholic? It's really funny. That's terrible, Panta. Yep. Yeah, Jeb in space was the first thing that I covered. Twitching, isn't that crazy? So, yeah, I mean, Crustacean, going with Challenger, it's underfunding. And, guys, like, here's the thing. HLS, underfunded. This pattern repeats itself. SLS, you want to hear something crazy about SLS? SLS was simultaneously at the same time over and underfunded and literally had the worst of both worlds. Seriously. Yeah, SLS was a train wreck, but there's a much, much, much more complicated reason as to why. But here, let me show you. I'll just draw it out in paint. Say, like, you have cost right here, right? I should get that tablet working. You have cost right here, and then you have time right here. Say, like, a normal, like a rocket, say, like a successful rocket program or a successfully implemented NASA program, say it works like this. As you go further in time, when the program starts, right, funding goes up, like this. And then, right here is where funding should theoretically peak. This is right out of NASA systems engineering. It should peak right here at first flight. So this is... Flight 1, first operational mission. Funding should peak. After that, after your subsequent test flights, your final test flights, funding should go down. It should go like this. And then it should flatline down here over time. If anything, it'll get lower and lower and lower and lower and lower until the funding and the lines converge, and right here is called disposal. Because, like, if you're testing a rocket, the more you launch, the more the price goes down, because the more you find ways to optimize the system over time. And then you have flight 2, and then you have flight 3, flight 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So, right? So now, let's look at the Apollo, let's look at NASA funding. Keep in mind, this is not an exact thing. This is spending relative to federal budget, but 58's right here, Mercury program is right there, Gemini program is right there, and then Apollo starts basically here in 1962. So you have the Gemini program bell curve, which goes up here and then stops right around there, and then it goes back down. As Gemini ramps down, Apollo ramps up, and Apollo and Gemini compounded on each other is how NASA got all the way up here. This right there is the Apollo program. That's Apollo right there. And then, look, 1967 right there. Apollo 4, first operational Saturn V mission right there. We hit the moon, we hit the deadline right here in 1969, completed the mission, so to speak, and then flew 6 more missions, out of 7 attempts to the moon, and then in 1972 right here, that's when the Apollo program went out, and that's when shuttle funding started. Now, 2 things from this. 1, bell curve, like exactly what I'm talking about. Bell curve. Second thing, you see that? That right there? So, 72, right here, shuttle program started. Look, they started the shuttle program with ramping down funds first, and then they flatlined it. They flatlined it in 73, 74, and 75, through 76. Nope. Look where that plateau is. Right in line with the Gemini program. Interesting, right? Crazy. They literally made the shuttle for the same price as that thing. Nuts, right? That's the first thing. Second thing is Apollo goes up, and even during operational missions, even if the Apollo program had kept going, it would have pretty much followed this funding line if they just kept using the Saturn V, but they didn't want to do that. We want to do reusability, blah, 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 blah. So, the shuttle never went up. You should have seen a bump in funding right here as you ramped up the shuttle program, and then it should have went down. Never happened. Even going up into operational missions in 1981 through 1986, NASA was still getting the shaft, right? And then Reagan and George Bush Sr. rolled out with the Strategic Defense Initiative, right? And they started ramping NASA's funding back up again for stuff like the Hubble, etc., etc. And then the Cold War ended, and NASA's been getting the shaft ever since. True story. Now, remember that bell curve that I told you about? Say this is 2013 over here, when SLS started. Where do you think we are right now? Where do you think we are? We're at Flight 1. Artemis 1 is going to fly. We're right here. So right here is 2022. What does SLS funding look like? Oh, you guys are going to get pissed. You guys are going to get pissed. Hokey gifted a sub to Ewok Pilot. Roundabout, you know. SLS's funding looks like this. True story. So, this is one of my gripes with SLS, and this is what Bill is trying to fix. He's trying to fix this problem. That's what that Senate committee meeting was about. They simultaneously overfunded it, and then right when it needed more money, they underfunded it right after that. Yeah. You wonder why SLS is taking a little bit of time. Well, first of all, building rockets to go to the moon takes about 10 years. Doesn't matter what you do. Takes about 10 years. I don't care what anybody says. It's a long and lengthy process because the factor of difficulty does not go down. It doesn't matter. Say NASA stopped SLS right now and they said, good, we're going back to Ares 5. If we did that right now, 10 years. Easily 10 years. That's if you get the funding. Look at SLS right here. SLS's origins go back to 2011, right when Constellation got canceled. That's 11 years. Not even a test flight. See what I'm talking about? The funding does that. It's linear. They for whatever reason, well, not I know the reason, but that's SLS's funding. That's no good. It has to ramp. If it doesn't ramp, you're going to get delays out the wazoo. And well, look what happened. Overfunding is just as bad as underfunding. Overfunding creates waste like you would not believe. Now, that's most of SLS's critics. You know, it creates a lot of waste. That's true. But then underfunding creates underperformance. Just like engineering a spacecraft, you have to follow that nominal line, and that doesn't always happen. And that's what Bill meant. Interesting, right? Anyway. Pretty crazy. I've heard that Von Braun designed the Saturn V to go to Mars. Would that have been possible? Sure. Now, here's the thing, fellas. You could say this is Congress's fault, but it's not. It's not Congress's fault. Congress did that as a visceral reaction because they tried to pull the plug on NASA's entire manned spaceflight program in 2010. Yep. You think it's bad going to Congress and saying, hey, the president wants to do this, it costs $1 billion, we need $1 billion, and Congress going, no, here, have 500,000? Going to Congress and saying the president doesn't want to do manned spaceflight anymore, we don't want any money, and Congress going, the frick you won't, you get money now. That's what happened. Yeah. Interesting, right? Wait, you want to stop the gravy train? Man, hell no! You know, funny how that works. Do you think SLS's funding affected its total cost? No. Well, that remains to be seen, Lazarus. The reason why it remains to be seen is because SLS hasn't launched yet. No one can tell me how much SLS costs because no one's launched an SLS yet. It's a very weird way of thinking about it. Now, there are projections. Sure, of course, there are projections. Duh. You can kind of extrapolate maybe how much it's going to cost, but I don't. Those are just theories. No one has a crystal ball. You can't tell me how much it costs. You haven't launched it yet. Interesting, right? Anyway, yeah. That was the short answer, Crustacean. Funny how that works, huh? All right, anyway, we got a little more NASA footage to watch from the OFT2 mission. Let's take a look. This is a drone shot, I think. I think that's what that... Oh, whoa. Hello. Oh. Oh, well, that's nice. That's pretty neat. Yeah, drone shot. Not bad.
Discovery, go and throttle.
That does not suck. Yeah, no, that footage is fantastic, dude. Oh, also, Jeb's in space. Seriously, the 0G indicator on Starliner is Jeb. Yep. Is that cool or what? I can't believe that. Quick update on the house. I sent out the purchase and sale deposit gig, better known as a down payment, today. I mailed it off, so the appraisal is next week. Here's hoping. Us and the sellers have come to an agreement. The last thing is the bank. I've never held that much money, albeit in check form, in my hand ever. It was well into the 5 figures, dude. I'm sitting there going, that's a lot of money. Where are you moving to? Brimo and I found a house, 04. It's in Massachusetts. I'm staying in Massachusetts. Because Brimo's job might not be remote. They might be, I don't know. So, whatever. I found a house, and we found a nice house. Pretty fair for the price, to be honest with you. And it has a freaking high bay in it.
Discovery, go and throttle up.
Seriously. There's an attached garage to this that the guy that's moving out ran his business out of. 15-foot ceilings, 1,000-square-foot garage with an office built into the back, attached to the side of the damn house. We're way past that point, roundabout. It's already been done. Don't worry. Whew. It's, yeah. The appraisal is the last one, geek. So the appraisal, basically... I gotta be careful. With the appraisal, dude... Now, okay, so it works like this. If you pay $100,000 for a house... I wish. If you pay $100,000 for a house, and the house is worth $50,000, once again, I wish, and you go to apply for a mortgage, the bank's not gonna give you 100 G's. Whatever they value the house at, they'll give you the mortgage for. They did this once, where they just gave you the money for the price that you bought the house at, and if you overpaid, the bank would just give you more money, right? That didn't end well. Yeah, that was not a good idea. Yeah, that was a bad idea. That didn't work very well. Now, don't get me wrong. 2008 was a bunch of other things. It doesn't help if somebody's a freaking plumber and they buy like a bajillion-dollar house and somehow get the money for it. Yeah, that's not that. Yeah, no, that also a bad idea. Yeah, lending rules are there for a reason, because yeah, that didn't end well the last time. We just said, yeah, we'll give anybody a loan, it's fine. So if they appraised the house at X price and I paid X plus 3, right? Say it's like $50,000 and I paid $53,000 and the bank appraised it at 50. I have to make up the difference. They're not going to give me the money for they're going to give me the money, the mortgage. They're going to give us the mortgage money for the price of the house. For the price that they appraised the house at. Simple as that. Yeah, predatory loans, Fit. Yeah, good times. Mm-hmm. Yeah, they also did the same thing with student loan rules, too, which is... Yeah. Yeah, fun fact, that the legislation on lax lending in the early 2000s also had student loans tied to it, the one that caused the Great Recession, yeah. Yeah, that had student loan stuff tied to it, and yeah, so they could give out student loans like willy-nilly, right? And yeah, they made student loan debt differentiated from housing debt, so when the bubble burst out, the student loans kept going. Yeah, true story. Yeah. Okay. But I digress. So, we got to have the appraisal. The appraisal's on Wednesday, and then I have 2 more walkthroughs through the house. The first is with the bank, and the second one with the bank during the appraisal. I'm going to be there during the appraisal. And then the second one is like the last final walkthrough before we get the keys, just to make sure that everything that we talked about getting done in the paperwork gets done correctly. And then that's it. And then it's just finalizing the paperwork from there. Hey, Yanni, what's going on? Have you sold your existing house? Joe, I live in an apartment, so no, this is my first time. Paint the inside and get the floors done before you move in, trust me. Roundabout, one of my good buddies is a general contractor. No, it's my cousin, but he's a general contractor. I had him come with me during the building inspection. Yeah, it's funny. Building inspector's like, that needs to be fixed. And he's like, yep, that needs to be fixed too. Yeah, them just agree with each other. It was pretty funny, actually. Yep. Going to have an inspector do the final walkthrough with you. Yep. When are they moving out? Ando, I don't want to say. Let's close first, and then I'll have that answer for you. So, yeah, that's where we're at. That's where I'm at with the house. Also, Jeb in space. Pretty cool, huh? I can't believe that. On the plus side, Tough Enough can be your moving truck. Yep. You already told us a week ago, if I recall correctly. Maybe I did, Hillness. I don't know. Yeah, check that out. So the Starliner made it up. It made it up to the space station. And then when it made it up to the space station, they opened the hatch, and Jeb was sitting right seat. So, is that Jeb? That's Jeb, dude. Yeah. Starliner has 4 seats. This is the pilot and the commander chair. The seat configuration, I forget what it is. I think it's like 2 and 2, like this. I think the other 2 seats are over there, but I could be wrong. It could be side by side. Jeb deserves more cushioning. Yeah. Oh, somebody asked this before. They're like, why do the seats look so uncomfortable? Well, the spacesuit is your cushioning in this design. Yeah, that's why the seats just look like a bunch of space folding chairs. Yeah, these are... The spacesuit is your cushioning. They did that on the space shuttle, too. The space shuttle seats look like folding chairs. Yep, 0G Jeb indicator. And Boeing is... Look at that. That's a real tweet. Can you believe that? I have a little bit more stuff for you on Starliner and OFT2, but before we do that, here, I am going to show you a couple of things here. Let's get rid of that. Already got rid of that. That's going to stay over there. That stays over there. That stays over there. Yep, there. Here, look at that one. Sergei Korsakov took this picture. He's one of the cosmonauts that's up there. Seriously, literally Jeb in space. That is a Kerbal on a spaceship. Nah, I haven't seen much, Sile. Yeah. Starliner presser? Fussist. Oh, cool. I'll check that out. Can you believe that? Kerbal actually in space. I really hope Felipe sees this. The guy that invented KSP. I hope he sees that. Because that's ridiculous, man. I can't believe that. Anyway, here's your cursed rocket picture of the day. Stop this! Why? No! 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 There's your cursed rocket picture of the day. Oh, man. And then also here, eye bleach. Here, check this out. Ready? This is footage from OFT yesterday. Oh, yeah, baby. That's nice. There's footage of spacecraft separation from the OFT-2 mission. Great, clean sep. I'm so freaking happy about Starliner. Now, when OFT-2 was going up into space, there was a lot of questions about the aeroskirt. Check this out. Novus, you linked this thread the other day. So this is Chris Coombs. He's the a hypersonics professor at I have to go look at it. University of Texas at San Antonio. So check this out. This is an awesome thread. You guys want to read? I had a lot of people asking me why, and I know one of the reasons, but this is a detailed thread on why Starliner has this aero skirt right there. It's a cylindric attachment to the bottom of Starliner. Here, check this out. First, let's get on the same page about what we are talking about. If it wasn't obvious from the first image, the questions revolve around a couple of changes to the OML of the vehicle near Starliner. An aerodynamic skirt and a series of black grids. Yep. Regarding the need for the aero skirt, after some reading, I'm pretty confident that I can explain this. For the grid structure, it's a bit less clear, but I'll make some educated guesses. So let's start with the aero skirt. The story came out in August 2016. Cosmic Andrew for sharing, describing some of the modifications made to the Starliner configuration. There were some enlightening quotes from Chris Ferguson referring to non-linear aerodynamic loads behind the vehicle. Interesting. They had one issue, a non-linear aerodynamic load issue where they were getting some high acoustic loads right behind the spacecraft. Yep. Outer mold line. Gotcha. Atlas V rockets carrying the Boeing cruise ship will encounter different aerodynamic and acoustic environments than on normal satellite launches. CST-100 Starliner will not fly inside a nose shroud on top of Atlas V as other payloads do. Okay. My first thought was to try and dig up some wind tunnel data. Alas, it is unsurprisingly not published, at least not that I could find, and it's highly likely that we'll never see it. But words like non-linear loads are often code for shock waves. NASA's technical report server time. NTRS for the win. I say this a lot, but it's true. Predictable and hilarious to me. Everything we do in this field is already somewhere on DTIC and or the NASA technical report server. So of course, there was a NASA report from 1962 studying this exact problem. Steady and fluctuating pressures at transonic speeds on hammerhead launch vehicles. The issue was more or less understood 60 years ago, is that if you use a hammerhead launch vehicle, so something that's wider in the front and then skinnier and then wider again in the back, you can experience some very large unsteady loads due to shock waves at transonic speeds. The geometry makes a huge difference. The key word here is hammerhead, and if you type something like hammerhead launch vehicle into Google Scholar, you can read papers on this all day. The appeal of this configuration is that you can mount a payload with a larger diameter than your rocket. Falcon 9 does that. Non-linear, does that mean exponential? No, not necessarily, Shy. There's linear, there's quadratic, there's logarithmic, there's exponential. there's a bunch of different, there's sinusoidal, there's a bunch of different things that could mean. The key, okay, so let's go down here a little bit more. This graphic illustrates the problem very well. At transonic speeds, Mach 0.7 to 1.3, you get a shock structure that can form just downstream of your capsule. This shock interacts with the growing boundary layer, separated flow, and oscillates rapidly. This produces large pressure loads. Yep. Nonlinear means harder to model? No. Nonlinear means that it changes. It's not just so. The loads, like, so if here, let's just read it. It's hard to. I don't want to pause this and. Yeah. Okay. So look, I don't want to pause my reading this, but here, why is it? The short answer is that see that shock. That shock changes. It changes shape over time in the transonic regime. Basically, loads go up and they go down, then they go up and they go down, then they go up and they go down. And that screws around with the airflow, and it screws around with the shock, basically. Chris said it better. This shock interacts with the growing boundary layer, separated flow, and oscillates rapidly and produces large pressure loads. This oscillating shock is reverberating off separated flow. You're getting sound. Sound is literally getting caught right here. Sound waves are getting caught between the OS and the SF right there. That's basically what's going on. That's the best way I can describe it. If I'm not describing it, if that's not a good enough analogy, you tell me. Basically, sound is reverberating in here. It's creating, like, the sound is bouncing back and forth. And that screws, dude, that creates all manner of crazy vibrations, right? Does it create pressure on the rocket body? Yes and no. You have separated flow right here off the bottom of Starliner, off of the end of the aeroskirt, and you do get a low pressure pocket in there, and that screws around with pressure on the rocket right there a little bit, especially right here and right there. Wherever the separated flow rejoins is going to be a hot spot, so to speak. NASA looked at how geometry impacts the pressure loading in a series of tests 30 years ago. The takeaway is if you have a low lift to drag for your hammerhead, it's too stubby, you can get some very elevated pressure loads right behind your capsule. The original Starliner had a lift to drag of 0.4. Let's see. Yeah, look at the different lift to drag for the different, interesting. See, this one up here kind of looks like, actually, this one down here looks like Atlas V's payload fairing. 1.2. In this particular case, a higher lift to drag basically means it flies better. It generates more lift than it does drag. 0.3 is not ideal. Does that lift to drag 1.2 configuration look familiar? Also notice that the most Hammerhead vehicles have a longer fairing section. Like I said, it looks like Atlas V 400. The 400 series fairing. Also Falcon 9. So Ares had that higher lift to drag in the design? Ares? Which Ares? Yeah, well, yeah, Ares 1. Yeah, that's why they went with such a longer upper stage. Yeah, part of the reason, right? I'm sure NASA, ULA, and Boeing had plenty of super smart people that were familiar with these design considerations. They saw the issue with pressure loading, and I imagine knew right away that the aeroskirt would be a quick fix. Not aesthetically pleasing to some, but that's why it's there. I actually like it. I think that's cool. Yeah, look. Look, it doubled the lift-to-drag ratio on the front of the rocket. That's pretty insane, man. More than doubled, actually. It's pretty cool. That's the difference there. This is the stuff Kerbal doesn't do this. Kerbal does not take this into account. I was always curious why there's a dual-engine Centaur on Starliner. The dual-engine Centaur is used for two things. They need a higher TWR on the second stage to limit G-load. Yeah, limit G-load to fly on a much lighter trajectory so they don't liquefy the payload, in this case the people on board. And it's better for engine out capability. So if one RL-10 fails, you can use the other one to get all the way into space. redundant engines are a good thing. I'll give you a case example. Falcon 9. One of the first Falcon 9 1.0s had one of its engines literally pop right after liftoff. The engine just blew up. Well, it didn't blow up, it shut off. So it used the other 8 engines to get up into space. Yeah. Yeah, you can go and check that out. Yeah, the engine failure, the other 8 engines made up for it. It's called engine out. Engine out is a good way to, I'm gonna say, make the spacecraft safer, but the right way is the right way to say that is more, you know, you're increasing your odds of success. So that's actually really cool. This is a great thread by Chris. Onto the part of the grid fin looking feature. As I said, I'm not quite as confident on the reasoning, but I have some guesses. I think, okay, I'm going to weigh in on this. I knew about the shock interaction for the aeroskirt. I explained it during the cast the other day. However, I think these are for a better center of pressure in the event of an abort. Because if I had to guess, Starliner is shooting the air out and around these grid fins. But I could be wrong. Let's see. Tori Bruno answered this a while back, but let's try to decipher the meaning. He mentions that the feature is there to manage the location of the shock attach point. Oh. Oh, look. He responded to Das. Those are for aerodynamic management. It helps to control flow around and past the skirt. The skirt is there to manage the location of the shock attach point on Centaur, which would otherwise be higher up and asymmetric. Whoa. You know what? Chris deserves a follow after this. I don't know what it is, T-Man. Let's see. One thing that happens with these oscillating shock waves on flat surfaces like this is that they have a way of moving around quite a bit and covering a lot of ground. That's not great. So it's possible this feature is there to mainly force the shock to stay in the same spot. Oh, I'm way wrong. I'm way wrong. Yeah. Yeah, no, this is a completely different thing. This would also provide some symmetry to the shock structure, which would otherwise oscillate in different ways in the axial direction. Whoa. Okay. This feature could also in part be serving to trip the boundary layer from a laminar... Okay, this next part is going to be Japanese, I know it. The feature could also in part be serving to trip the boundary layer from a laminar transitional state to ensure it's fully turbulent. This would help manage flow separation, keep flow attached longer, and also make the shock interaction more predictable. Yeah. Yeah. I gotta read it again. I gotta read it again. This feature could also in part be serving to trip the boundary layer from a laminar transitional state to ensure it's fully turbulent. Okay. This would help manage flow separation, keep flow attached longer, and also make the shock interaction more predictable. So, that cheese grater structure on the outside of Starliner, and this is me asking a question now. That's there to make sure, that's basically there to break up the air in case the shock interaction starts going down the vehicle, right? Am I wrong there? It is a DRS, basically, Ginny. Yeah, kind of. Not necessarily, though. Here, let me try to draw it out.
Discovery,
see if this. Hey, Donnie, what's going on? So, okay, you have Starliner, right? Here's your service module, right? There's your service module. At speed here, I saw it kind of modeled there a second ago. Here, let me. Like that. There is your window, right? And then your door is over here. So, air, when it shoots past the capsule, right? So this is on the ascent. When it shoots past the capsule, it's going to go like this. Right? So you're going to get extremely high pressure right here because the air is being pushed out of the way. The point at which this happens the hardest, like when the most amount of pressure is generated here during ascent, is called... Anyone? Bueller? Anybody? Max Q. You got it. Yep. Basically, that's when the air gets compressed so hard against the vehicle that it causes a compression load. It basically scrunches the vehicle like an accordion. You don't want to do that with your rocket. That's not a good thing to do. So, we're not really focusing on that. We're focusing on this area right here. Okay? So what's going to happen here is the air is going to get shot off, right? And that shock thing that they're talking about, right, means that you have extremely high pressure right here and extremely low pressure right there, okay? So this is actually going to create a vacuum, all right? The vacuum is going to go up here. Air is going to actually get sucked in and it's going to swirl around in here, okay? And what that effect looks like is something like this. Let me do air with blue, I guess, right? So some of the air is going to vortex, just like wing off the edge of an airplane, just like air off the edge of an airplane wing. It's going to vortex because you have high and low pressure swirling together. So what that's going to do at certain speeds is make the shock, make this, how the air is moving in here, it's going to literally be different. And the air will end up going up like this and coming out like that. Right? Because air is going to go around and get sucked up and then go down there. So, they're referring to this shape right here. That's what they're looking, that's what that means, okay? So, you're going to basically create a huge vacuum in here, and that vacuum is going to change the shape of this. Because air is going to get sucked up in this area right here. Now, so like say Starliner's aero skirt is down here like this, right? Let me just draw the rest in here. Right? Say Starliner's aero skirt is there. The air is going to come up. It's going to fly off, and then it's going to go right back up here, and that's going to change the shock shape. At certain times, the shock shape could go all the way down here. You'd get a huge, huge pocket of fail in there. You don't want that. That's bad. That's bad. They're talking about regulating this right here. That's what that grid thing does. So Starliner has that, you know, the cheese grater around the sides, right? It does look like a cheese grater. Be quiet. And what that does is that basically makes turbulent flow in here. It makes turbulent flow so that shape stays like this. And it stays consistently like that during the entire ascent. What? Why? So what? Who cares? Why is that a big deal at all? Like, all right. Well, one, if I'm understanding that right, that thing, you don't want that to get too big. If you get too big, the center of pressure moves too far forward. The front makes way more drag. This is why lift to drag is important for the front of the vehicle. You want to make more lift than drag. You make more drag, center of pressure goes forward, bye-bye. I mean, also lift too, to an extent, but regulating this also regulates, basically tells you where this shock is going. This shock is going to go out, and then it's going to go down like this, right? And by making sure that that shape stays exactly the same throughout the entirety of the transonic regime, we'll make sure, like here, let me draw a different version of Starliner right here. Right, there's Atlas, there's the Centaur, right? Go Atlas, go Centaur, go OFT2. Right? You want to make sure that those wakes don't do this. You don't want the wake to push out here and then come in and hit right there on the conic interstage. Yeah, that will do bad. That will do a bad for the vehicle. That will do a very bad. Because the angle right here, the angle of shock changes. It changes throughout transonic regimes and into supersonic. As actually, believe it or not, it starts like out here, and then as you go faster, it'll end up going down here somewhere. Now that's a theta. That's theta. Theta for shock angle, if I'm remembering right. I don't know. I forget. So like as the vehicle goes faster, this goes down here, and you really want to make sure that wake, when it's coming back in, goes down here and reattaches. You get attached flow on the booster. You do not want attached flow right here. Because if the flow comes in, the airflow comes in and it reattaches down here, then it's going to do that. This right here, bad. That's bad. That's going to create all kinds of vibrations on the vehicle and move your center of pressure so far forward that the vehicle will just rip itself to shreds. Yeah, that's bad. You don't want that. That's going to create a lot of drag. Says theta, right sphere. Yes, they're both are used for different angles and shock waves. So, Jock, what you just said is that I wrote the wrong thing because I wrote the right thing. Nice. Yeah, good to see that your head's in the right spot. So, the little cheese grater right there, and this is me just basically visualizing it from what Chris said. Basically makes it so this shape, it forces the air up in a certain way to make sure stuff like this doesn't happen. It basically makes it nice and uniform. It makes that shock nice and uniform throughout the entire ascent of the vehicle, all the way up into space, which is actually really freaking smart. That's really cool. That makes the vehicle much more predictable throughout the entire regime. That's actually super interesting stuff. Now, if there's anybody here that knows this better than I do, am I on the right track? Yeah? If they're using a cheese grater, you'd think they'd be going to the moon. Hey, we don't know if Starliner has BLEO capability, Jim. It might. You should post that visualization on Twitter. This one? Nah, I'm good. I think I got that right. I think, but I'm not sure. I would defer to Chris's judgment here. He probably knows more than I do. Why not put it in a version of Atlas that has the long fairing? Weight. Starliner's heavy, man. Weight. Delta V probably has something to do with it. Why would you build the whole dang fairing if you could just build a little aero skirt on the bottom, right? Less material manufactured literally achieves the same result. And I would add, Laz, that you need that cheese grater. Even if you did do that, you'd still need it. One haircut? What? I'm confused. So wait, Jeb gets to go to the ISS and I don't? To be fair, Jeb's a little bit cooler than you. Damn! Yeah, I think that wanting the aerodynamics to be uniform throughout the entire ascent's probably a good idea. That's actually really cool. Now, other rockets achieve the same result by having a longer fairing, right? But Starliner can't do that because it's a stubby boy. It is a stubby boy. Give me 1 second. Emotional damage. It's stubby capsule. It can't do that. It's actually really cool. Really interesting stuff. You're a stubby boy. No, you're a stubby boy. Damn, skibbity bop. Jeb is stubby. No, you. Aren't you a little short for a Kerbal? Huh? Oh, the uniform. No, wait, what? Hey, I just finished putting my ring station around Maho. That's clean, Maz. That's real clean. I like it. Looks good, man. Yeah, I also want to just reiterate why we're talking about this, because they did Jeb on Starliner. Just like they did helicopter on Mars, and they did surgery on a grape. They did Jeb on Starliner. No, seriously, I've said it 3 or 4 times this space news. I don't care. It needs to be reiterated. The 0G indicator on the OFT-2 Starliner mission is Jeb. I don't care how many times I have to say it, that will never not be cool. Can you believe that? Yeah, awesome. There was a mention of it during the welcome ceremony this morning. Link the photo? Sure. You just did a flyby of Eve for the first time. Cool. Cool, cool. He forgot his helmet. He didn't forget it. Jeb has faith in Starliner. Here, let's keep reading what Chris has to say. You can also see shocks that impinge further downstream on the rocket body and cause similar problems. The grid structure might be helping to manage how that feature behaves. Computed mean RMS pressure load on the model. Oh. Yep. 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 That you can see shocks that impinge further downstream on the rocket body and cause similar problems. The grid structure might be helping to manage how that feature behaves. That's what he just said is what I just drew. That's smart. That's really freaking cool. If I'm off base with this, Tori Bruno, please jump in to correct me. The gear you showed me the other day, I made use of it. Yeah! Isn't it? Luiso, that's great. I love it. Hybrid tech, man. That's the future. The last thing I found was some other cool images that I didn't end up using for the thread, but I wanted to share it anyway. Let me see. Yep. Yeah, see? Yeah. Computed surface pressure at Mach 0.8. So right into the transonic regime. Look at, see, blue is lower pressure. Look at that. And look at the flow is going out and then it's coming back in. At the edge of transonic. Look at the... Ooh, hello. Science! Oh, I love this. This is sick. Yeah, see? See, I told you, this is at Mach 0.8. Look at where the shock's going. The shock's going almost it's going radially off the vehicle. And then as that speed gets higher, the angle of this will go down here. That's actually really cool. And look at how much low pressure is built up right there. So you can see the darker areas here, right, are where higher pressure is. Look at the pressure off the end of that thing. That's crazy. That's really cool. I love aerodynamics. That's so freaking interesting. It makes sense. It's basically a stabilizer. The cheese grater is a stabilizer. That's cool. But it's a stabilizer for air that's going backwards up the vehicle. Yeah, here, look at this next picture that Chris shared. Yeah, see? This is why you don't want that shock coming back in, because it'll compound with that and you'll get a huge amount of drag right here. Unless you want to do that, there might be a vehicle design where that's warranted to stabilize it. Like Vega. Vega C, for instance, might do something like that. Who knows? But see, check this out. Density derivative in the vicinity of the body at Mach 4.7. See, once you get into supersonic, look, the angle goes down instead of out. It doesn't go this way, it goes that way. Gasp! Yep. Yeah, Mab. It's really freaking smart, dude. Oh, yes. Yeah, see, look, there's longer fairing. Yeah, see, look at that. Look. No, as I understand, the cheese grater makes sure the shockwave is at a certain position and does not move too much, which gives acoustic loads. At transonic, you have buffeting, which makes shockwaves dance all around, which is no bueno. Yeah, no, first, actually, Jock, when I explained it the other day, all I said was that it helps prevent sounds from reverberating around. Yeah, it was not a detailed enough response, but yeah, that's cool. It manages the shock so the sounds don't bounce around. Not so much for aero, but it regulates the airflow in a certain way, not necessarily for aero, but for acoustic loads, which is cool. That's basically vibrations. You know, you could say that capsule has good vibrations. Because giving me the excitations. I'm picking up good vibrations. Chat, no, don't get mad. Look, Jeb, look. Jeb. See? Jeb. The terminal angle where the shockwave stops is roughly equal to arctan V vehicle divided by V sound at that altitude. That's wild stuff, Engine Uber. Only tangentially related. Not sure if you saw the For All Mankind. I gave up on For All Mankind in season 2. Zeros. Yeah. Seeing astronauts with M4s on the moon firing weapons that are air-cooled in the vacuum of space kind of killed it for me. Like, what the hell are you doing? The gun would melt after like 3 shots. Just blow on it in the vacuum. They're going to shooting M4s in space. I'm like, what are you doing? Oh my God, who thought this was okay? Okay, so if you missed that, I'm annoyed because For All Mankind has people shooting air-cooled weaponry on the moon where there is no air. Oh, oh. God, what are you doing? Who thought this was an okay thing to do? Just simply put some air on the moon. Yeah, I guess so, right? Like, oh, God. They even have the M4s have the foregrip that has the air cooling mechanism on. Like, why did you send that into space? What are you doing? You're ruining it. Goes 18. Oh, very nice. Very nice. I don't want to talk about it anymore. The ammo already has the oxidizer. No, Blue, I'm not talking about that. Air-cooled weaponry. I'm not talking about how the bullet goes out. Yeah, no, the cartridge will work just fine. But there's this thing that guns do. They get hot when you shoot them a lot. That happens. But also, in the vacuum, heat can't it can't convect. Those guns use convection. They exchange the heat with the air around you. That's how they, don't break. And even here on Earth, if you put too much brass through a gun too fast, you're going to warp the barrel. Because heat. And now you put it on the moon where there's no way to convect heat. Because it's in the vacuum. Once again, air-cooled weaponry on the moon where there's no air. You'd fire that thing like 3 times and the gun would melt. It'd just stop working. Or you'd get a squib, in which case, yeah, have fun with that. Hopefully it doesn't fragment and blow a hole in your suit. Which is just lovely. Just lovely. It's like, okay, that's great. Anyway, Jeb's in space, by the way. Yep. It was the special white paint. Oh, yeah, the white paint, sure. So bring back the Lewis gun with the water jacket. Got it. Bauxy, where does that hot air go that you made? Where does the steam go? Sorry I brought it up. I know some liberties in the show were dumb. Yeah, Zeros, it's fine. It's okay. They're a special space-cooled edition. Why don't you just throw a spear at somebody instead of shooting them? Or just a bolt action? Bolt action rifle would work just fine. Like, why are we using gas impingement? It's just I'm sorry. It's like seeing a gun get shot on the moon, at least in the show, is about as unrealistic as, like, you know, say like they landed on the moon and there's like a Corvette on the surface of the moon. They're like, yeah, we landed this Corvette. It'll work. It'll fly around because it's a Corvette. It'll work here. Of course it'll work here. And them just driving around a regular car on the moon. Like, that's how unrealistic that is. It's like, what are you doing? I mean, I'm not going to sit here and say that I don't want that. All right? That, to be fair, it's an alternative. It's alternative history. It's an alternative history Ewok where the Apollo program never stopped going and the space race kept going into the 70s and the 80s. And somehow NASA still ended up with the space shuttle, which is just... What? That's correct, Long-Eyed. The moon has a little bit of an atmosphere, but it's not anywhere near enough pressure to breathe. There is some air, so the guns could work theoretically. That's why I said it'll fire like 1 or 2 times, and then it'll probably... It's not enough air to exchange the heat. I don't know, Creeper. The fighting in space with guns is only in the final 2 episodes. Everything else before that is just relationship drama. Yes. Let's watch a movie. Or watch a series about space where they're only in space for 2 episodes. Okay. Did they send a space shuttle to the moon? I don't want to talk about it, Metroid. I don't want to talk about it. Yeah, original, this isn't Planet Druidia, okay? The atmosphere doesn't just stop. It falls off exponentially over time, meaning that pressure exponentially drops the further and further you go. Technically, some of Earth's atmosphere is out at the moon. The moon's gravitational pull pulls some of that air that way. True story. That's why the moon has some air. It's literally it's scavenging bits of Earth's atmosphere that are up there. Yeah, pretty crazy, right? But on Earth, it's not cooling a ton within the short time frame of dumping a mag either, no? So you should be able to go through a mag or 2 before you have to let your gun cool for a week or so. That's not how heat works at all. There's no, it's a vacuum, Jock. There's nothing up there. There's nowhere near enough air to radiate that heat. It's no way. You'd fire 3 shots and the gun would jam. That's not how that works at all, dude. No, if you can like mag dump 2 or 3 mags, right? Like on Earth with a gun that's air cooled before it really starts to have problems. Honestly, and that's radiating or that's convecting the heat. You can't. That doesn't happen on the moon. You'll fire like 3 or 4 times, right? And then the thing will just jam. Your gun would be cryogenic in the shade. Not necessarily. It would get cold, obviously. But you'd still fire it and the heat would still go nowhere. Imagine a 1911 with huge radiator panels. Well, you'd need a Maxim gun. You need something like an M1917 or a Maxim or something that's water-cooled. But even then, where do you put the heat? Where do you put the heat? It stays in the water. Okay, the water absorbs all the heat, becomes steam. Same problem. Same problem. Just use the gun inside of a refrigerator. There you go. Now you're talking. So, let's make a tank. Dude, a tank lunar rover, right, where the inside is a refrigerator is more believable than them just firing guns around. Just the lit gun. Seriously, just get a needle and just walk up to the guy. It's not like he's gonna hear you. Just get a needle, walk up to the guy. Psst, that sucks, and then run away. Like, a gun is way overthinking this problem. Just get a needle. Ha ha! Hole in your suit. Frick you, man. I'm out. A crossbow, something. Yeah, just pop a hole in the guy's suit. Just pop a hole in his suit and run away. What is he gonna do? Chase you? He's leaking air. You can plug the hole. Oh, if you poke him in the back, try doing this with a spacesuit. No way, man. Spring-loaded nail. Yeah, a nail gun would be better. You know? Oh, my goodness. Yeah, no, Zeros, the second season just lost me. I was watching the second season. I was just like, nah, I'm good. I don't need to watch this anymore. All right. Jock, what's that? What's that? Most of the heat is rejected through casings and gases. Heat conduction and convection from the gun to atmosphere is not super quick in order of a few seconds. All right, you seem to really want to prove that point. All right, fine. Sure. I'll concede that your gun would be able to fire more than once. As stupid as that is. Here. All right. Okay. For all mankind. Give me one moment. I gotta find the right shot. I mean, Jock, since you're an expert with this, all right? Since such a big expert here. Here, let's try this one. Yeah, explain that one, doofus. What about that one? Hey, how does that work with physics? Jock, this is a joke. I know with more Delta V you could get it up there, but also, if the gun thing isn't going to do it for you, is that going to do it for you in the realism category or unrealism category? What is going on here? Reduced payload? Oh my goodness. Doors closed. 250,000 miles from the moon and you have the payload bay doors closed. Jeb is gonna find a way. I can't even right now. I can't. Zeros, I'm sorry, man. I just can't do it. And that, you know, it's not even for all mankind. I can't do it with any space stuff anymore in movies, because it's like a can of worms that you can't put the worms back in the can. Once you know how space flight works, you'll see all this stuff, and it's like really hard to enjoy the movie or the show. And I'm sure for all mankind, I'm sure people love it. It's fine. I can't do it myself. I see the shuttle floating around at the moon, and I'm like, that may as well have been the Millennium Falcon. I'm just sitting there going, oh no. The Expanse is fine. Yeah, I don't mind The Expanse. That's because it works within the confines of the physics that they set up in the show. They even had an entire episode explaining on how their drive systems work, which is great. That's fine. Oh. What is your favorite space TV related movie? From the Earth to the Moon is pretty good Wednesday. I don't know if that counts. What do you think about Interstellar? It's alright. Yeah, Nerva, I just can't do it. I see the shuttle floating out in the moon. I'm like, wait, one, if For All Mankind is supposed to be a continuation of the Apollo program, why does the shuttle exist? because the shuttle existed. The shuttle existed because the Apollo program got canceled. So the shuttle, which existed because the Apollo program got canceled, somehow found its way into this universe where the Apollo program didn't get canceled. What? Ow. Ow, my face. My face, it hurts. Stop. Make it stop. Is there a chance of getting some MSC after KSP? Nope. Nope, we'll just wait until next week. Yeah, and even then I actually might not be able to do it next week. I have the house appraisal on Wednesday. Yeah, still no. Like, and I just... It's difficult with all the house stuff to make up. To, like, usually, like, if I miss something, I try to make it up another day. Right now, just throw that out the window. I'm just way too busy, man. I'm sorry. Nope. But the shuttle got Nerva. Oh, yeah, let's make something the size of the space shuttle and put a nuclear engine at the back. Yeah, sure, what's the worst that could happen? It'll be fine. It'll be fine. Metroid, I don't understand. I don't understand because, like, Garrett Reisman was the technical advisor on the show. But I don't know if he was the technical advisor for Season 2. Garrett Reisman has been to space multiple times. I've met him. I interviewed him on stream one time. He's a good dude. I know he's a good dude. I know he knows his spaceflight stuff. I don't know. Something must have gotten lost in translation there. Either that or they just wanted to make a story, which is most likely, and they took some creative liberties here and there or something, but yeah. The nuclear shuttle. Just... what? Why? I think it's they didn't listen. I think they wanted to make a story, Metroid. That's what's going on. What the frickin' frick is this? Hey fellas, what does that do? I got a question. What does this do? What's that little stubby way? Is this Dream Chaser? It's for the Wi-Fi. Oh, okay. It looks cool. It's the XM satellite radio. It's the Starlink antenna. Aren't Starlink antennas flat? Why is the landing gear... What? Oh, it hurts. It hurts, man. I can't do this. I can't do it. I can't do it. I can't do it, man. What are you doing? I can't do it. Why did the shuttle get fat? Why did it get fat? It's fat. It ate too many hamburgers. Oh no, not Kennard! No, not Kennard! Needs more Kennards. Oh no! Hans Bricks. Oh no! Thank you, whoever that was. Jesus Christ. Oh my gosh, I needed a good laugh, dude. That's pretty funny. It looks pregnant. Why? Oh my god. But here's the thing. I can't watch it. Zeros, I can't freaking do it, man. That does not mean that it's a bad show, and it does not mean that you can't enjoy it. If people enjoy it, watch it. Whatever makes you happy, right? Like, emotional damage, right? Dude, how are get rocket pregante? I'm so Rory. Oh dear. Oh dear. Pathfinder flies to the moon.
Discovery.
Has thermal protection system designed for low Earth orbit re-entry. Okay. Okay. Look at Hired's link to vomit. Wednesday with a 7-month resub. What about this? Yep. Okay. Yeah, I'm not even showing that on stream. That's, yep. Nope. Nope. fat shuttle for more fuel tanks in the wings. I'm pretty sure the entire shape of the shuttle Akabidi is the way that it is in real life to, you know, not have a fuel tank shoehorned into the back. So if we were going to design a shuttle that did have an onboard fuel tank, we wouldn't just take the shuttle's design and make it fat. That usually doesn't work that way. I'm just putting it out there, man. I'm just putting it out there. Like, yeah, it would look something like this, you know? You must like this, I bet. Is this... You can always just launch 2 shuttles at the same time. Kill me. Hey, fellas. Hey, fellas. Hey, fellas. Hey, fellas. Can you tell me why that wouldn't work? Who's coming with me, man? Who's paying attention, man? It's too stubby to be able to manage the... Who's coming with me, man? Who's coming with me, man? The shock reverberation loads on the sides of the vehicle. The upper stage is missing? No, it's Falcon 9 1.0. Yeah. Too stubby. Too stubby, boy. There you go. And also, oh, I got rid of the Jeb stuff. No, alright, whatever. Let's just go look at Double Aries 1. It's too stubby to handle the shock loads. Yeah, it needs the cheese grater. Bingo. Also, no cheese grater. Bingo. Yeah, where are the legs? Don't worry about it. Q. Yes. I mean, I'm not going to say that I don't want that. I'm not going to say that I don't want this. I know, dynamic pressure, yes. Guys, okay, this is a good design, but what if we... I like those 5 segment boosters, but what if, you know, like the shuttle external tank's supposed to go here? How about we just take this? We don't need 2 of them. We only need 1 because it's an upper stage. How about we just take that, put it up on the top, and then just take, like, an external tank and put some RS-68s down the bottom? Because expendable vehicle, you know, like... You think that'd be... That's just direct. Shh. 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 We should do that. It's a good idea. Isn't that SLS? No. Police. Is that Fish Jenga? No. No tears, chat. No tears. Only dreams. Also, boop. It'll be fine. Okay, so I wanted to start this stream out by start the Space News out by showing you guys this. So this is over at Edwards Air Force Base. And if you go peeping around Edwards Air Force Base, you go to the NASA side of things, which is on the north side, or the northwest side of the lake bed, right? You see 2 4-segment SRBs just kind of chilling. Those are shuttle boosters, right? That's pretty cool. You also see some X-34s and F-18s being cannibalized for parts. Yep, don't like that. Don't like that. But there are some SRBs right here, right? See that? Now, I wanted to start the stream, but everybody wanted to talk about Jeb in space. So we started talking about Jeb in space. But I wanted to start the stream like saying that I know where those SRBs are heading. Those SRBs are heading right here. Collect Space reported this the other day. Check this out. More than a decade after it was grounded, NASA retired Space Shuttle Endeavour is soon to be the focus of a groundbreaking ceremony. California Science Center in Los Angeles is set to begin construction of the Samuel Oschin Air and Space Center, a new museum that will display Endeavour vertically, as if poised for another launch, complete with a real external tank and 2 side boosters. It will be an incredibly dramatic display, but it will also allow us to put on display the whole system. Yep. And there are said SRBs. Yep. Those are real SRB casings from the shuttle program, coupled with ET-94, which was a leftover LWT tank design, but a real external tank from the shuttle program. NASA switched to the SWLT design, a super lightweight tank design to increase payload capacity, and this tank wasn't needed. But that is a real external tank. So Endeavour is going to be stacked inside of a building at the California Science Center that they're working on, with real SRBs and a real external tank and obviously a real orbiter. Should have just built it on the ML. Now, that's what I would have done. Zeros, that's what I would have done. I would have paid to have the mobile launcher. I would have paid to have the mobile launcher taken apart and then shipped piece by piece over to California, but that I don't think the museum has the money to do that. But there's dud engines in the orbiter LEOP, which is kind of annoying. The reason why there's dud engines in all 3 of the remaining space shuttles that flew into space is because they needed the engines for other purposes. Which kind of blows, but oh well. Rocket Guy, what's going on? So, actually, you know what they could do? The tail service masts are still at Kennedy Space Center visitors, if I'm remembering right. The real TSMs for the shuttle. The real fueling umbilicals are still around. I'm wondering, like, maybe they should add them. No, you. Yes, they're there. Cool. But they're gonna do this at the California Science Center, man. Yeah, Endeavour is currently just inside of a hangar like this. And it is cool, don't get me wrong. That's really freaking cool, actually. It's just a shame. Such low mileage. Why couldn't NASA just make new engines for SLS? They are. They did it to save costs, Ewok, which still I think is funny, but it's to save costs. You only have enough shuttle engines for 3 missions, but that's kind of how it went. Oh well. Well, better late than never. It has taken them 10 years to get to this point. Who cares? It's happening. Who cares how long it took? It's gonna happen. You really need to come to Germany. I've been in the payload bay of Buran. It's pretty great. Yeah, one of these days, dude. So yeah, the only place you'll see a full shuttle stack with all real hardware, except for the shuttle engines and all the parts that they gutted out of Endeavour when the program stopped. But hey, whatever. Real orbiter, real tank, real SRBs. Now, where is this? Let me show you. The shuttle was a beautiful design. I hope they one day revive them. I don't think they'd ever revive them, Ben, but I also want that. I don't think it'll ever happen, but could. Okay. All right. All right, roundabout. Okay, new plan. New plan. We start an online banking service and make lots of money from that, okay? And then we cash out, and then we start a spaceflight company, right? And, you know, we can't remake the shuttle program right away, right? Because there's no way we have the money to do that. So we'll make a extendable or expendable launch vehicle, and that will eventually convert to be partially reusable over time and get some experience in reuse. And then when we make money, we'll bring back the shuttle program. And then prove that rapid reusability is a good idea. And then, you know what we can do after that? We can buy a social media platform and start an electric car company. Think it would work? We'll call it The Expanse, yeah. I heard about that somewhere. Wait a minute! You're a forward thinker. Could you do the plan in reverse? Acquire a social media company first? Davros, I'm not sure I'm smart enough to do that. Just don't buy a private jet. Yeah, okay. Yeah, to be ahead of his move. Yeah, that's a good idea. Anyway, what we're talking about here is California Science Center, which is right next to the Coliseum. And it's over here. You know that this is the California Science Center, right? And that there's a space shuttle near here it's pretty easy to tell. That there might be a space shuttle here. Not so much for like this building or the triangular building here or that building so much, but that might have something to do with it. Yeah, yeah, there you go. Endeavor is in here. The shuttle's in here with the ET. I don't know where they're gonna make this building. Does anybody know? Here, actually, you know what? Maybe we should go read. I saw you teaching her how to read. You never taught me how to read. Which is why I still don't know how to read. Set to rise adjacent to California Science Center's main building, the Samuel Austin Air and Space Center is expected to take about 3 years to complete. Additional details, including when Endeavor's horizontal exhibit will close and when the vehicles plan to go vertical, is expected to be revealed on June 1st. Endeavor's current exhibit helped shape the plans for what's to come next. They just said it's adjacent. I don't know what that means. No, Pythos. We don't want to do that. That could end poorly. But also, I mean, do you want the shuttle program back or not? I'm gonna go ahead and guess that it's probably gonna be like right here or something, because I don't think they'll put it by the A12, which is pretty dope. Oh yeah, I forgot that that's there. One of my favorite passenger liners, dude. A12 just sitting there. Now, fellas, here's the thing. We can sit here and get annoyed that all these planes are outside, but you got to remember, they're in California. I wouldn't worry about it too much. California stuff don't rust. It does not rust. You could store planes outside, and they'll be just as good, almost just as good as they would be inside. It's dry. Totally fine. That, and I wouldn't worry about the SR-71s or A-12s. You can literally store them outside. Titanium does not rust. Titanium does not corrode. It just stays titanium. Yeah, fun story. Well, I don't know that for sure. Actually, yeah, no, that's right. Yeah, titanium, yeah, you don't need to worry about that. That thing will be fine. Yeah, it'll be fine. Yeah, so like the F-18 that's over here, looks like an F-104 glued to the side of this building. Convair Oh, the Convair. That's so freaking cool. Convair 990. Or no, that's an 880. What's that aircraft on the side of the building? Looks like an F-104. And then... yeah, the California Science Center is really, really cool, by the way. It's really awesome. There's all manner of spacecraft in there. All kinds of spacecraft. Obviously a space shuttle. That's pretty neat. Not familiar with the Convair. Convair 880, roundabout. The 880 and the 990 were it's more about the 990, which is a derivative of the 880 right there. So Concorde and the Tupolev 144 are the two fastest passenger liners ever to fly, right? You want to know what the third fastest is? No, Zizep. It's not football season, so I'm not thinking about football. Yep, the 990, third fastest passenger liner ever. Ever. It can fly in transonic. It can fly in the transonic regime. Yep. That thing can sit right at like Mach 1 and just keep going. Yeah, it doesn't fully break the sound barrier, but it was designed to just sit there. Convair couldn't match Boeing and Douglas when it came to producing things, so what they tried to do is make an airliner that was faster than the 707 and faster than the DC-8, and they succeeded. It's still the third fastest passenger liner here. The only things that go faster are the Concorde and the Tu-144. True story. Yes, Jam, there is. Mm-hmm. Or the shuttle. The shuttle's not a airliner, but the shuttle does go faster. There are plenty of planes that go faster than the 990, but we're talking passenger liners here. We're talking jet liners here. Yeah, roundabout. It's really cool. Now, think about how ridiculous that actually is to make a passenger to make a jet airliner do that. You know how that aero skirt on Starliner that we were talking about a little bit earlier is not necessarily there for aerodynamic. It's to manage acoustic loads that are caused by aerodynamics, right? Because the transonic regime gets really, really strange. From 0.8 Mach to 1.3, air starts doing some really weird stuff. Air and sound start doing weird things, right? So look at the blisters on the back of the wings on this plane. Is the transonic regime more fuel efficient? No. No. This is a jetliner from the 60s, man. Fuel efficiency was not a thing. Fuel efficiency was not a thing. Brute forcing things was absolutely a thing. So Convair on the 990 used they used these engines. The CJ805. See that? Pretty nice engine. It looks like a Hustler. Oh, like a B-58, which Convair also made. Yeah, true story. So these CJ805s have a military designation. They have a military designation. That's the civilian version. You want to know what the military version is? The J79. Yep. Yeah. Anybody that knows anything about J79s know J79s are good for doing one thing. Going extremely freaking fast. Yep. Yeah. That's an F4 engine. And an F104. Yep. Oh, Bay. That's the plane that's glued to the side of the building, for the people that are wondering. Yeah. Oh, baby. And also, Convair, the B-58 also has those. Yeah, that actually has J79s on it. That has 4 F4 Phantom engines on it. It's designed to go fast, and I'm pretty sure it did that pretty well. Ooh, speaking of Convair. Oh, don't show me that. Don't show me that. Don't show me that. Have you seen the Convair Sea Dart? Yeah, the seaplane version of that. Not that, but yeah, I have. I know exactly what you mean. The Hustler, yep. Did you ever do a dive into the Avro Arrow? Avro Arrow is actually designed to do something pretty similar to this, only kind of in a more interceptor form, Hasty. But yeah, Canada's last domestically produced airplane. Oh, no, Conair is something completely different. Yep. Also, J79, baby. 7-stage axial compressor with reheat. So the 990 doesn't have this part over here. See this part? It doesn't have that part. It's just this part from here forward. The U.S. wants its own Ekrenoplan. Yeah, I read that article that you linked yesterday. Interesting. Is that a bypass engine? Nope. Turbojet. J79 does not have a bypass. It's just straight yeet for a jet engine. Yeah. Conair, don't they make drivers? Hair dryers? Yeah, they but they also made movies. For some reason I thought there was a bypass looking at it. Where's the bypass here? I don't see any bypass, do you? Nope. 7-stage axial compressor. Actually, it might be more than 7-stage. I don't know. Let me look at it. Oh, starter motor. Very nice. Actually, let's read for a second. Oh, no, not 7. 17. Oh boy. Actually, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, that's a lot of compression. No wonder this thing made so much thrust. Yeah, that's pretty nuts, actually. Yeah, that's a lot. So notice how on each fan, the inner diameter of the blades gets bigger and bigger over time, but the outer diameter stays the same. The air gets sucked in, and then it gets squeezed in here, and then it goes through this inlet, through those holes, into what's called a combustor. It gets blown up, it gets combusted, and then it gets blown out the back. And out the back, there's more of these blades. There's more of these blades that are attached on an axle that turn the front. Suck, squeeze, bang, blow. Jet engines. Literally combustion. Yep. How much thrust? J79s, Alex? Oh, comparable to a rocket engine. I'm dead serious about that. They're dude. A small rocket engine, but a rocket engine nonetheless. Take a look. 11,800 pounds of thrust. 52 kilonewton dry. With the reheater, 80 kilonewtons of thrust. And an F4 Phantom had 2 of those. 2 of those. Makes 160 kilonewtons. That's, what is it? 36,000 pounds of thrust on full reheat because frick you. Because frick you. Like, that thing is almost as powerful as 2 RL-10s. It's pretty nuts, man. That's like an upper stage engine. It really is. The F4, by today's standards, is still one of the fastest fighter planes ever made. That thing's still... It can go just as fast as like an F-16, F-15, F-22. Oh, yeah. Now, what those other planes have on this design is that those other planes can do this thing that planes sometimes need to do. It's called turning. Yeah. The F-15 can do that. The F-4... the F-4 can not... Yeah. Yeah, it doesn't really do that whole turning thing very well. Yeah, the F4 cannot supercruise. It needs reheat. Yeah, because the F4... not very aerodynamic. Yeah, not very aerodynamic. You see how it has dihedral out on the ends of the wings, and then the stabilizers are anhedral? Yeah, these are all fixes that McDonnell Douglas had to make up for the fact that they made a plane that's about as aerodynamic as a toilet. True story. Yeah. It's true. What? It's a very fast toilet, though. Dude, that's the thing. It don't matter if you have 160 kilonewtons of thrust on tap. It don't matter what you make the plane. You can make it look like a flying toilet, and it kind of does. I don't know why. And if you think I'm bashing F4s, the F4s are one of my favorite fighter jets ever made. Because who cares when you can go faster than everybody else? Who cares? Frick your maneuverability. I can go faster than you. Off stream, 95, off stream. I love F4s. F4s are my favorite. I love that plane. It's so cool looking. It's one of the, dude, it is one of the coolest. Look at that thing. That thing is sick. Oh, dude, that is a nice looking plane, man. MiG-21 go burr. You know what the funny story about that is? The MiG-21 is literally, it's the same. The MiG-21 is the same idea. It can just go fast. Doesn't turn very well. Oh, hey, baby. Can it take off from carriers? Yeah. EMO, the F4 Phantom was used. The Air Force, the Marine Corps, and the Navy. Yep, all variants used it. Yep, it can fly off carriers. It can fly. It has multiple different variants. It was the F-35 of its time. The F-35 isn't the first time they tried to have one airplane serve all branches of the military. The F-4 was the first one to do that. Everyone used it. Dude, we made millions of, not millions, we made a lot of them. I don't think we made millions. I'd have to go look. There's so many F-4s. Every museum has a freaking F-4. Every air museum has a 50. They made 5,195. They made 5,200 of these planes. 5,200. That's a lot. That's a lot of F4s, man. Oh, that poor F4. That poor Plen. Plen is not happy. Oh, I like this picture. What do you think about the Gripen? It's okay. No gore. Yep. Attention, here's the NASA Media teleconference press bingo card. Nice. Yeah, I like this picture. Those are two of my favorite planes. Yeah. 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 Those are two of my favorites. See, I like this one because speed, and I like this one because screw you. GAU-8 Avenger Cannon, when you absolutely have to eliminate every Soviet tank on the battlefield. That looks like Germany to you? Well, it's painted in woodland camo, Jock, so that means the A-10s that were painted this color means it's in Europe, so 3 craft from the U.S. Air Force in Europe in flight on April 6, 1987 near Ramstein Air Base in Germany, so southern Germany. Yeah, good call. Yep. Ever heard of the Pardos push where one Phantom kept another one flying by pushing it by the tail hook? I've heard of that, Hellfish. Vaguely. I read about it once. Yeah. F4s are crazy, man. They're a crazy plane. I love them. I think they're so cool looking. But honestly, cool looking doesn't mean performs well, to be honest with you. They took the lessons learned from Vietnam and that plane, and then they made this. Oh. I like that. Actually, the funny thing is the Navy took the lessons from the F4 and then they made this. They took the lessons from the F4 of Vietnam and made that plane. This plane makes me feel feelings. Swept wings make you thirsty. No, I'm with you. I'm with you. Yeah, no, I'm with you on that one. Oh. Boom. I feel the need for speed. The Navy needs another Hellcat? Well, just buy one from Dodge. F-14. Happy Navy noises. Who doesn't love a Top Cat? Answer, the maintenance crew. Yeah, it turns out when you add more features to a plane, it gets more complicated and they're hard to maintain. Can you imagine what the salt air did to the swing wing mech? Oh, that nope. Don't want that. Do not want. F-16 go brr. Yeah, fly by wire. Okay, guys. You used to maintain the avionics for F-14s. That's cool, man. It's freaking cool, dude. Roundabout, that's like one of my favorite parts on Twitch, dude. I can talk about a plane, and somebody in chat will just be like, yo, I worked on those. I'll be like, all right, that's cool. I play Kerbal for a living, bro. Like, that's neat, you know? Absolute favorite, a MiG-25. I always thought the 29 was the best MiG, personally. 28s, though. Why not make a carrier that hovers on the sea? No salt water that way. Not sure if you already shared this stuff. Yeah, Creeper. I said I had enough links, and believe it or not, I didn't even get through all of my links. But, okay. All right. I have to look at this. I gotta link this, man. Greg Scott has pictures down the Cape from a flyover. Oh, there's also that. I didn't even get to this one today. We didn't even get to discuss Appendix N. Anybody notice a couple of things about this? But there's also this. Alpaca! You saw it, Rocket Guy, huh? National team split. It looks like Northrop Grumman and Lockheed said, now we'll do this ourselves. We didn't even watch NSF yet. I just didn't get around to it, man. Yeah, Greg Scott, look at took more of these pictures. Look at that. Nice. The Lockheed Martin entry looks like a fat Lego man. Greg Scott has more pictures. Wait a minute, what were those? Oh, tents, okay. What are those? Posts. Orbital launch mount posts. Grumman can at least say they've done it a few times before. Yeah, Curly, I'd like to say that. I'd like to think that they have some experience in the matter. Anyway, they've almost got all the launch segments made. You see that? Unreal. All right. So, NASA added this, Appendix N for Sustainable Lunar Development. NASA selected 5 providers in September 2021 to develop lander design concepts, evaluate mission requirements, and mitigate risks by conducting critical component tests and advancing the maturity of key technologies. Maybe you can help me. I cannot remember that one aircraft that howled when it flew at a specific speed due to the air intakes. B-52 does that. Hey, oh, no, but wait a minute. Dynetics is a Leidos company? Are you sure? I I don't know what kind of tipped it off, man. How did you know that? That's really, yeah, I think you're right. You've heard that it is a Leidos company? All right. You could tell it's a Leidos company because of the way it is. What does a Leidos do? What does Leidos do? Leidos is a defense contractor. They make all kinds of stuff. If you're in the States and you're a fan of the TSA, so, can't say that with a straight face. They make the scanning equipment. Yeah, Leidos makes all kinds of stuff, dude. The TSA. Yo, I love the TSA. All right. Oh, that's good. So yeah, let's see. Check this out. I'm from Canada and I don't love the TSA. Yeah, that's your favorite part of flying. Yeah, to have some guy fondle your junk before you get on an airplane. Yeah, that's great. Sounds like fun, man. So let's see. Let's look. So it's interesting because Blue Origin still has national team written on theirs, but also Lockheed Martin and Northrop Grumman. It's for safety. Oh yeah. Yeah. Yeah, for safety, right. Okay. It was the Vulcan XH558. Vulcan XH558. Oh. Oh, yeah, the Avro, of course. That's not the XH558. Just call it the Vulcan. Yeah, that thing howls. Yep. They could still be a team, but if you already have all the elements yourselves, why not try and be the prime? Worst case, you use a small number of resources to write a proposal. Yeah, that makes sense, Rocket. Dude, I'm not gonna lie to you. I kind of really dig the standardized diameter. Now, Rocket Guy, I'm no expert, but that diameter looks to be about 7 meters. Yeah, I would say, judging by the ladder, looks to be about 7 meters. Gee, I wonder why it would be 7 meter diameter. Yes, but the very tall ladder is not great. So then there's the Alpaca. Dynetics nixed the drop tank idea, which is actually pretty cool. That's neat. Yeah, they nixed the drop tank idea. That's actually a very big lander as well. There's that chonker right there. It doesn't look like it fits in Starship. Yeah, I know, right? What's Northrop Grumman got over here? Let's look at this. Interesting. Interesting. Rocket Guy, you see that? There's a door on the descent module. Yeah, no, Jack, that's probably not a good idea. The blue descent stage looks a lot different now. I wonder if Blue Moon changed as well. Ian, I like this. I like this a lot. I think that looks really good. I think that's you guys can say whatever you want. The transfer stage idea, I think, is, I mean, I'm not really fond of a 3-stage lander. I like this solution over here. But it's interesting because these definitely look like 2-stage solutions here, Lockheed and Northrop. And what's interesting is that, add to this out of context. What is this? That's your favorite part of flying. Yeah, to have some guy fondle your junk before you get on an airplane. I did say that, didn't I? Yep. Yeah, I guess I did say that, Pi, huh? Oh, man. Yeah, yep. Nope, I did say that, didn't I? Oops. Sometimes you get unfiltered, EJ thought, and yep, that was one of those times where that happened. I'm not gonna deny that one. No, no, I said that. Truth in advertising. Oh my god! Wait, can I play that one? Can I play that one more time? Just one more time. What's your favorite part of flying? Yeah, to have some guy fondle your junk before you get on an airplane. Yeah, that's great. That's your favorite. The way I said it, though. That's pretty funny, man. That was just unfiltered thought. I wasn't even trying to be funny. You fondle your junk when you get onto the airplane. Oh dear. Emotional damage. Oops. Wait, one more time. One more time. That's your favorite part of flying? Yeah, to have some guy fondle your junk before you get on an airplane. Yeah, that's great. TSA, we fondle your junk. You know, I want to be very clear. I'm not laughing with myself. I'm laughing at myself. It's pretty bad. I know you are too. Don't lie. Oh, that's like Discount Rick. We fondle your junk. A Lidos company. Oh, man. Can we go back to looking at landers, please? Oh, Rocket Guy. Okay, what are you saying? Let's get back on the right track. I don't know if Northrop's Grumman design will maintain that lower hatch as is. Based on all of their landers, they don't have enough propellant, unless they're using cryos or have a third stage. Just my opinion. Also, it seems to mess with any symmetry. I don't like all of the landing engines either. Yeah. Angry Lego man. Fondle your junk before you get on an airplane. How did I say it like that? It's so stupid. Link to this, please? Sure. Yeah. Or just put A. There we go. I'm a Lockheed Martin guy, but it does look like an angry Lego. Yeah. Dynetics design is pretty cool. I like that design. That's an SSTO. It's single stage, get from gateway all the way down. The thing is, it just kind of looks like a shoebox. But doesn't matter how it looks. The LEM looked like a... The Apollo LEM just looked like a bunch of parts that, like, you threw a spacecraft in a blender or something, and that's what you got out of it. And yeah, Rocket Guy, that's definitely an Orion-derived descent module. That's what they were using for the ascent module on the national team, correct? I actually like Blue's design here. All one stage like that. I like that. The ladder is kind of meh. Hey 12, what's going on? Yeah, not bad. I wonder how feasible it would be, Rocket Guy. Just on a quick side note, Blue's design's very curable. Which of the three has the most time in the moon time? Northrop Grumman, because Grumman designed the lunar lander. And that brings me to, that actually is a good segue here. Oh, nice one, Zister. That's cool. Did you know that your company has a stake in Dynetics? Do you know they're a Lidos company? I don't know if you knew that. How will the Dynetics lander fit into a rocket? Sideways, Les. You know what's like kind of interesting, dude? I'm wondering why. Well, I know the answer to this question. Anything is feasible if you have enough money. How crazy would it be to like just upgrade the limb? Could we do that or? Nice, Jim. I'm wondering, like, do you think we could just? Or better yet, why don't we just make the limb again? You know, like, could work. Isn't that what Northrop Grumman did? It kind of looks like it's lunar module derived roundabout. Yeah, Altair was like an upgraded limb. Yeah. Wasn't the fuel on the ascent stage of the LEM extremely toxic? And descent stage Stavarus? Yeah, most spacecraft use hypergulls for on-orbit operations, man. Yeah. CSM, Apollo CSM did, the LEM did, Space Shuttle, Dragon, Starliner, Orion, they all use the same propellants. Because they use these hypergulls because they're stable for long periods of time on orbit. You don't have to worry about boil-off or anything. Yeah, let's make the LEM and restart the Saturn V while we're at it. Can you imagine friction stir welded Saturn V? Friction stir welded aluminum isogrid Saturn V? With upgraded F1Bs and J2Xs in the second stage? At that point, it's probably better to just scrap for new and improved design. Lockheed Martin required the massive service module to get it to low lunar. Would need to be a lot bigger. You can thank the ESM for that shortcoming. Yeah, I know, Rocket Guy. Better, you know, while we're at it, let's just get the Block 2 CSM up and running again, dude. Modern design F1s. F1Bs, go. Look it up. F1Bs are insane. F1Bs are if you took the RS-68 and an F1 and combined them into one engine. Oh, yeah. Ablative nozzle F1B with an open cycle, which was just... it was such a good idea. Lunar module, not Lockheed Martin. I'm stupid. Lunar module required the massive service module to get it to low... Yeah, that makes a lot more sense now, Rocket Guy. I was like, what are you talking about? Lockheed Martin, lunar module. Okay. I wonder, like, how legit, like, can you imagine if we just took the CSM and just... I mean, that's basically what Orion is, like, to be fair. But it's got an ATV-derived service module that can't get it to where the Apollo did. Yeah. Rocket Guy, I personally, this is EJ being an armchair rocket scientist, I personally think that Orion not being able to get down to low lunar orbit is adding way too many single fault redundant systems into your architecture here. All these frickin' things that can go wrong with all these things. Starship, well, maybe not Starship. Starship is the one that kind of, you know, if something goes wrong, you don't really need to worry about fuel. You'll get home, you know. How much stuff and weight could the LEM take down to the moon? The ascent module, 2 people, their spacesuits, and a lunar rover, and a couple of other things, lads. It's a good amount, dude. Good amount payload to the surface. Why not mix of an F1 and an RS-25? Because that's 2 different things. You guys, here, look. F1B. 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 Oh, this very good. Well, at least the James Webb Space Telescope proved design can work with 300 plus single fault point failures. Yeah, I know. Rocket Guy, you know how many times I had to explain just because something is single fault redundant doesn't mean it isn't going to work? A freaking doorknob is single fault redundant. How often does that not work? A toilet is single fault redundant. They clog. No. Freaking only has 1 water line going in. And another great EJ take. A steering wheel is single fault redundant. Technically, a steering wheel on a car. You don't see people saying, well, we need 2 steering wheels now. A single fault redundancy is bad. Is Blue Origin expecting to finish development of New Armstrong by the time their lander are ready? I don't know, Bagel. Maybe. Ah, Bagel, you reminded me. New plan. Can we just take that F1 and just make this instead? Can we, like, you have one of those that's near you, right? We could just do that. You're single fault redundant. You only live once. Yeah, you're not wrong. Wow, that's depressing. You ever notice how people don't say YOLO anymore because all the people said YOLO, did something stupid, and then died? True story. I was actually looking at it outside all day. Nice. No, don't bring YOLO back. Darwin called it. Yeah, man. Saturn V. Saturn V with 5 F1Bs in the first stage. And then 5 J2s in the second stage. Friction stir welded aluminum iso grids. Or ortho grids like Vulcan. I wonder how much, Rocky Guy, how much mass do you think you could save by doing it that way? YOLO as a speed run for Darwin Awards. Oh, yeah, that makes sense. That makes sense. Yeah, no, I get it. That makes perfect sense. What I meant was the mix of F1 and RS-25s was to cool the nozzle in the same way the RS-25 does by pumping the fuel around the nozzle in the engine. Alucard, the F1 engine did that with the liquid oxygen. Yeah. The F1 engine already did that. It's closed cycle, and it used film cooling because the nozzle got too hot. With the F1B, you get rid of all that, and you make a simpler motor. You make a much simpler motor by having it be open cycle, right? You have an open cycle design with film cooling, right? But you have an ablator nozzle instead. Way, way easier to make this than it is than that one. Oh, I thought they used gas cooling. You have LOX going through the channels up here, and then you have film cooling going down. The channels go up, film cooling go down. The F1B is designed to take all the complexity out of this and make it way simpler and easier to manufacture. That was the idea. Okay, hear me out. Raptors. Saturn V, but with Raptors instead of F1s. I don't want to throw Raptor engines into the ocean, Creeper. I don't want to do that. F1Bs, though, that's fine. They look a lot like the engines from the twin bore. Yep, yep. Yeah. I'm thinking about it, man. How, like, take a Saturn V, you could save so much mass with modern manufacturing techniques on, like, just like remaking the Saturn V. Now, don't get me wrong. What I'm talking about is a multi-billion-dollar effort because remaking the Saturn V is complicated. The Saturn V, when it was made 50 years ago, was also very complicated. Now, keep in mind that what I'm talking about is all relative here, but I wonder what the performance gains would be with a Saturn V with 5 F1Bs. I honestly think on the S1C you could eliminate the intertank design. They put the intertank design on the Saturn for structural purposes. If you could eliminate the intertank and switch to a common bulkhead on the first stage, you'd save a lot of mass, man. You could save a lot of mass by just replacing all the analog systems and replace them with modern digital controllers, right? Yeah, Rocket Guy, yeah. You could just attach your iPhone to the LEM and it'll land it. Can you imagine? Stir welded isogrid aluminum first and second stage with F1Bs and J2Xs. Dude, that. What do you think the payload capacity increase would be here? Saturn V in its Block kind of 2 variant, when it stopped flying, could move 120 tons. 120 metric tons into space. Dude, I think you could get another 120 tons out of it easily. I mean, all those weight savings. If you went with composite interstages too, like. Man. Wow, we should have just done that. That would have been way smarter. Hey Siri, land in the Sea of Tranquility. Okay, landing at the Red Lobster. Calculating route. No! Damn it! Use J-79s for the first stage? Ah, too heavy. Too heavy. Rocket engine good. Nice, Curly. That was pretty funny. I hate Red Lobster. Dumb question. Why didn't they just go back to the Saturn block for returning to the moon? They wanted to use the technical expertise crustacean from the shuttle program. All the technicians that worked on the shuttle program would be great, considering all the technicians from the Apollo program were gone. You gotta remember, your technical expertise, having all the people there that know what they're doing, was seen as a way to make the vehicle a lot cheaper. It's not just reusing the hardware. If you do it right and you ramp down one program and you ramp up the other program, like what we were talking about at the beginning of Space News, you could theoretically reduce cost because you have people that have experience. That was the idea with Constellation. They would make shuttle-derived vehicles because they could retain the entire shuttle program's user base, right? Like, you don't need to... If it's all shuttle-derived, you don't need to retrain astronauts too much. You don't need to retrain your technicians. You still have all the guys that build the vehicles, right? You can still build the vehicles. You just do some slight upgrades. That was the whole idea with Constellation. And then we didn't do that, and then we fired all those technicians, and then decided a little bit later that we still wanted to make a shuttle-derived vehicle. And then the price went... Yeah, true story. Yeah, we talked about that, though. Yeah, that whole linear funding curve as opposed to a... Yeah. Oops.